Imagine lying on soft grass under an endless night sky, quiet and vast. The air is cool and still. Above, countless stars are scattered like diamond dust, each one shining with a faint, gentle light. The darkness around them feels like a velvet cloak, enveloping you in stillness. In this silent cosmic night, the sky seems to breathe slowly, as if the universe itself is taking a deep, peaceful breath. You can almost feel the steady, calm rhythm of the night. Even in this deep darkness, the sky holds infinite secrets. It feels as if the stars might speak if we listened closely enough. In this deep night, even sound itself seems to disappear. In the vacuum of space, there is nothing for sound waves to travel through. Yet in your mind, you wonder what the night sky might sound like if we could truly listen. Perhaps you imagine a gentle hum or a soft, singing whisper carried on solar winds. Distant stars might tick like calm, steady heartbeats. The universe might have its own silent music just beyond our ears. Inside this hush, it feels as though every part of the universe is waiting for its own moment to speak, softly, on its own time. You breathe and feel the cool air. Even as your chest rises and falls gently, your own heartbeat adds a quiet rhythm to the night. In a way, you are part of this cosmic stillness, a small drumbeat within a grand silence. Each breath becomes a reminder that life flows, even in the quietest moments. The darkness around you does not feel empty. It is filled with countless distant lights. In stillness, you become aware that the universe is listening back in its own timeless way. Letting your mind wander further, you realize that in this peaceful moment, you can imagine even the faintest signal reaching you. It might be a soft wave of energy, perhaps too gentle for our ears, but present all the same. Feel the cool night air on your skin, smelling the earth and dew-kissed grass around you. Perhaps there is a light breeze carrying the scent of pine or wildflowers. Each breath you take is deep and gentle, calming your mind further. You notice how your chest rises and falls rhythmically in this peace. There is no hurry, no urgency, just this moment of calm and quiet. With each inhalation, you sink deeper into rest. The tall grasses and leaves sway softly, as if respectfully whispering back in the stillness. Look up further. The Milky Way spills across the sky like a river of milk, its countless stars blending into a soft, luminous band. You may see dark patches where cosmic clouds dim the light, making it seem even more magical. On the horizon, a bright speck might be a planet, glimmering steadily. Each star, no matter how tiny, seems alive in this darkness. They wink and shimmer, as if sending a gentle greeting. Even the familiar constellations seem more alive tonight, urging you to find shapes and stories among the points of light. Notice how truly quiet the night is. Aside from a distant owl, or the rustle of leaves in the gentle breeze, the world feels hushed, even if the earth below you is full of life. In this moment, you feel far removed from it. The silence here is soft and kind, allowing your thoughts to float freely. Each passing second feels stretched, as if time itself is resting. There are no alarms, no demands, just the gentle rhythm of your own breath and heartbeat in harmony with the universe. In this stillness, you become more aware of yourself. Your heartbeat is steady and slow, a quiet drum beneath the night sky. You are part of this moment. Your energy mingles with the quiet surroundings. Perhaps you feel a subtle sense of belonging. This place is both intimate and infinite. The boundary between you and the vast darkness blurs. In the silence, you sense that a piece of you is in the cosmos, as the cosmos is in you, connected by this shared quiet. For countless generations, people have looked up at this same sky in wonder. Ancient peoples mapped heroes and beasts in the stars, using constellations to guide and inspire them. Now you share that kinship. In this moment, you stand among a long line of dreamers, connected by the same silent awe. You might trace out shapes in the starlight yourself, the same constellations guiding and inspiring you now. The names we give these stars are like echoes of humanity's search for meaning in the dark. As you lie here, a sudden streak of light might cross the sky, a shooting star burning silently through the night. It is quick and bright, yet gentle. For a brief moment, you share the sky with that swift traveler, a reminder that even fleeting moments can be beautiful. You breathe deeply, releasing any tension. Here, under this silent sky, you feel small, yet perfectly at ease, wrapped in the gentle calm of something infinitely bigger. The night sky is patient. You could lie here for hours, letting your mind wander or empty itself. Minutes stretch into moments of eternity. Time seems to slow down around you. In this sacred silence, the sky cradles you gently, without judgment, just presence. You are completely at ease, carried in the arms of the night, listening to the peaceful heartbeat of the universe. But then, deep in the silence, a subtle shift occurs. A faint murmur in the void, barely perceptible, begins to emerge from the darkness. It is like the softest whisper, brushing the edges of your awareness. The night holds its breath as a secret moves just beyond the reach of your senses. You lean in slightly, heart echoing the stillness, waiting to catch the faintest sign. This quiet moment feels alive, as if the stars themselves are leaning closer to tell you something. Humans have built gentle giants to listen to the night sky. Far from any city lights, enormous dishes point their faces to the heavens. They open quietly, like conch shells inviting the universe's whispers. By day and by night, they remain patient, straining to pick up the faintest calls that our eyes cannot catch. These radio telescopes are our humble way of meditating with the cosmos, turning technology into a tender act of listening. They seek soft signals from distant galaxies, hoping to understand the secrets carried across the void. Some stars whisper in their own way. There are distant pulsars spinning calmly, flashing in a steady pattern like cosmic lighthouses. Others send brief bursts of energy, flickers that seem to blink into existence and vanish almost as quickly. These fast flashes might sound dramatic, but to us they feel like gentle sparks in the dark, soft pulses in the cosmic hush. Even these signals are small and faint, more like curious fireflies dancing in the night than thunderstorms. At night, with patience, we can feel their quiet presence, hints that the universe is alive with secrets. Even our own star, the sun, has its quiet voice. Soft ripples of solar wind drift through space like a gentle breeze, sometimes carrying tales of distant storms beyond our solar system. Though these sounds are beyond human hearing, they remind us that the cosmos is never truly silent. At times, Our instruments catch a soft hiss from the sun, a tiny echo of the star's life. These gentle solar songs speak of charged particles dancing in magnetic fields. But to us, it feels like a soft murmur, connecting our story to the star above. Since ancient times, people have spoken of the music of the spheres, the idea that the heavens create a hidden harmony. Perhaps this is true in a way. The pulses and waves from distant stars and galaxies combine into a gentle cosmic symphony. We may not hear it with our ears, but we can sense it with our minds. For a moment, it feels as if each tiny spark of light is a note in that melody, each flicker a gentle chord in a cosmic lullaby. In moments like this, you can almost feel that the universe is singing softly, a melody woven from light, silence, and whispers. When two massive black holes collide, or a supernova erupts, the universe quivers. Yet even such mighty events reach us as the softest of murmurs. They send ripples across the fabric of spacetime. But by the time those ripples arrive here, they are like gentle vibrations on a pond, long after a stone has sunk. It is as if even the universe's greatest fireworks have turned into lullabies when heard from this distance. These might be called the deepest notes of the cosmos, low and far away, humming below our normal perception. In moments like these, you too become part of the chorus. As you breathe steadily and your heartbeat thumps quietly, you feel a connection to those distant pulses. It is as if your own rhythm joins the cosmic song. The night air feels alive with possibility, and in your mind, you drift on the currents of space and time. Here, under the stars, you are both listener and participant in the gentle symphony of the universe. Sometimes you might wonder if we ourselves have called out to the stars. In fact, humanity has sent a few messages into space, radio broadcasts, and deliberate signals, all aimed at letting someone out there know we are here. But the universe does not respond quickly, if at all. So for now, in the stillness of the night, you remain patient and quiet. Someday, maybe someone or something will reply. But whether they do or not, this moment of listening is its own reward. As you sit and listen, you realize you are part of a grand cosmic tapestry. The elements in your body were forged in ancient stars. You carry a piece of every distant sun within you. In a sense, each gentle pulse from the heavens is already part of you, and each breath you take is a continuation of that stellar rhythm. Here on this quiet night, the boundaries between yourself and the cosmos blur. You are both the listener and one of the notes in the universe's melody. In the vast silence, every gentle signal feels precious. When the universe is mostly quiet, a single pulse or whisper becomes beautiful and clear. It is as if you are sitting by a silent lake at dawn, and only a distant bird calls. That single note resonates through the calm air. Every cosmic whisper you've heard tonight is like that. A solitary voice making itself known in the deep quiet. It reminds you of the balance between silence and sound, and how much wonder can hide in the softest of moments. You cannot know what these distant songs truly mean. Perhaps they are natural cosmic music, or messages waiting to be understood. The mystery itself is a gift. You relax into the not knowing, letting curiosity gently wash over you. Here, under the stars, you allow yourself to dream of what might be out there, listening and hoping quietly. The universe has its stories, and you are content to listen to each gentle chapter as it unfolds, one whisper at a time. Imagine a single radio telescope on a remote plane. As it gazes out at the sky, it hears nothing but a faint static and the hum of distant energies. But that static is full of secrets, too subtle to catch with the naked ear. If you close your eyes, you might almost hear its gentle song, a soft drone that swells and fades like breathing. It tells you that even stillness can be rich with life, if you listen deeply. And as you listen, you realize there is something more behind those individual notes. A faint, constant hum in the background, always there. It is as if the universe itself is breathing softly behind every whisper, a steady undercurrent beneath all you have heard. You sense it filling the space around you, a subtle presence that ties everything together. Beyond the stars and galaxies, there is an even deeper stillness, woven with the softest static. When instruments are tuned to the sky and the radio dial is left open, a gentle hum emerges from every direction. It is as if the universe itself is breathing in the background. This cosmic static is very faint, but infinite in reach. It might sound like radio hiss when no station is playing, but to us, it feels like a warm, comforting blanket that stretches across the sky. Human minds have captured a bit of this cosmic static too. In quiet corners of our planet, scientists long ago recorded this ancient hum. When played back, it sounds like a ghost of the universe's infancy, a soft whisper from the dawn of time. Even now, with the right equipment and a truly silent night, one could almost tune in to this primordial signal. It is a hum from the origins of everything, gentle and ever-present, telling the story of the cosmic beginning. Often it is called the cosmic microwave background, a faint glow left over from when the universe was newborn. You can imagine it as the sky's oldest melody, still echoing softly across the eons. It is always there, hidden behind everything else we see. If the universe had a favorite song, this would be it. A gentle rhythm that has survived since the first heartbeat of creation. In our antennas today, this background is only a soft hiss, barely above silence. But it carries something profound, the quiet memory of everything that has happened since the beginning. Think of the times when you've tuned a radio to an empty frequency. Even then, there is a faint hiss. Some of that comes from distant lightning storms or Earth's atmosphere. But beyond that, there is a gentle, constant glow. Much of what we call static is actually a message from space, carried on microwaves and radio waves. It's everywhere, in the air you breathe and the ground beneath you, a reminder that we are surrounded by the echo of creation. This static isn't random, it has patterns. Scientists who study it have found subtle ripples and variations within that hum. Those tiny differences hold clues to the shape and history of the universe. If you let your imagination wander into the static, you might picture it as waves or ripples on a cosmic lake. These are the very wrinkles left by the universe's birth. Over billions of years, they grew into galaxies and stars. So in this gentle background, you carry within you the seeds of everything. Now, as you sit still under the sky, you realize this static is all around you, truly filling the entire sky. It's like wearing an invisible cloak of warmth that wraps the cosmos. You feel it more as a feeling than a sound, a subtle presence that envelops the night. Even though you hear none of it, your senses trust its existence. It reminds you that you are part of something ancient and everlasting. You close your eyes and sit very quietly, letting that realization wash over you. Without needing your eyes to see or ears to hear, your mind opens to the idea of being part of this cosmic silence. In that quiet, the static's presence feels comforting, like a familiar embrace at the edge of your senses. The night air is soft around you, carrying that ancient song. All you have to do is listen, as deeper stories swirl just beyond the veil of the stars. The cosmos remains quiet, yet wise, inviting you to stay here in this silence, feeling the presence of something vast. Long ago, the universe was young and filled with light. Everywhere was warm and glowing, a sea of brightness that filled all of space. This was the moment of creation, when everything began to take shape. As time passed and space expanded, that light stretched into longer and longer waves, cooling as it went. Now, billions of years later, that original light has become a gentle whisper of microwave radiation. The sky is everywhere filled with this remnant glow, though it is incredibly faint. It is like the afterglow of a sunset that still colors the sky long after the sun has set. Everywhere you look in the sky, it is there. A faint, uniform glow in microwave light. Astronomers speak of it as a message from the first moments of time, telling the story of how the universe was born. But you don't need a telescope to feel its presence. Just sit in silence under the stars and imagine that you are bathed in the oldest light there is. It might be too faint to see with your eyes, but it is a soft reminder that the universe remembers its own beginning. In that silence under the stars, you are wrapped in the soft afterglow of creation. It's like a gentle warmth that has travelled across the universe to meet you here. Even if you cannot see it, there is comfort in knowing that this whisper of light surrounds you always. The universe has recorded its own beginning, and right now, it is letting you listen to its lullaby. In this hush, it feels like you are hearing the last echoes of that first light. It is the universe's lullaby, a reminder that even the biggest stories began with a gentle moment of quiet. You are listening to a lullaby older than any other, meant for all time, a soft song that started when the cosmos was just taking its first breath. Tonight, the sky remains a lullaby, and you are the quiet listener. The story of the universe continues to unfold, written in every quiet pulse and gentle glow. But for now, let the night hold you in its embrace. The galaxies will keep turning, and the stars will keep whispering. But here in this moment, the universe is at peace. You remain content to listen in wonder, as the galaxies and stars whisper their secrets. The quiet journey goes on, inviting you to never stop listening. One night, under an ink-black sky speckled with starlight, a faint cosmic heartbeat was heard. It came not through human ears, but through a giant radio antenna listening to the heavens. A steady click, 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 echoed from the loudspeaker, each pulse so regular it was as if the universe itself had a ticking clock hidden among the stars. Astronomers huddled around the receiver in wonder and puzzlement. Could this be a signal from an alien civilization, calling out across light years? The pattern was unnervingly precise, repeating every few moments with unwavering rhythm. That mysterious beacon from the darkness was eventually traced to a strange and wonderful source: a pulsar. Pulsars are the rapidly spinning remnants of massive stars that have lived and died. When a star much larger than our Sun reaches the end of its life, it explodes in a supernova, leaving behind a tiny, dense core. That core, only about 10 miles across, yet containing more mass than our Sun, becomes a neutron star. It's hard to fathom such density. A single spoonful of neutron star material would outweigh a mountain on Earth. In this crushed state, atoms themselves cannot survive intact. The core is essentially a city-sized atomic nucleus of pure neutrons. And if this spinning stellar core beams energy our way, we perceive a pulsar. Late one evening in 1967, at Cambridge University in England, a 24-year-old graduate student named Jocelyn Bell noticed something odd in her telescope's data. She had been patiently scanning the sky with a special radio telescope, looking for the flickers of distant quasars, when an unexpected signal caught her eye. On the long roll of chart paper, amidst the jagged pen scratches of noise, there was a peculiar set of marks, a series of pulses too regular and steady to be noise. It was a faint blip that pulsed about once every second, like a heartbeat hidden in the static. At first, she thought it must be an earthly interference or a glitch in the equipment. But night after night, the pulses returned, always from the same patch of sky. This was no accident, and no man-made signal. It was as if a star itself were ticking off seconds, far out in the darkness. As Bell and her colleagues scrutinized the strange signal, a thrilling possibility arose. Could it be a message from an intelligent alien civilization? The pulses were so precise that it seemed almost conceivable. In jest, they nicknamed the source LGM-1, short for Little Green Men 1. But before long, another source with a similar pulse was found in a different part of the sky, and then a third. The idea of aliens dimmed as it became clear these signals were a new kind of natural phenomenon. In the months that followed, the mystery was solved. These were the beacons of an unimaginably dense, fast-spinning stellar remnant. They had discovered the first pulsar, a neutron star flashing its lighthouse beam towards Earth. Imagine a star's corpse, no larger than a city, spinning faster than a figure skater pulling in her arms. Some pulsars rotate dozens of times each second, and a special few whirl hundreds of times a second, an almost incomprehensible speed. Picture an object more massive than the Sun, condensed into a sphere only the size of a city, spinning so rapidly. If you could stand on its surface, an impossible feat, you would be carried around at a significant fraction of the speed of light. This incredible motion, combined with intense magnetic fields, shoots twin beams of radiation out into space. Spin by spin, these beams sweep across the sky. From our vantage point, when one of those beams crosses Earth, we detect a pulse. To our radio telescopes, it's a periodic flash of radio energy. If we convert those signals into sound, we can literally listen to a pulsar. The first pulsar's rhythm, pulsing about once every 1.3 seconds, sounded like a calm, metronomic tick, 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 each beat separated by the length of a deep breath. It was steady and unyielding, a heartbeat from 2,000 light-years away. Not all pulsars tick slowly. Some spin faster, their pulses blending into a hum. The Vela pulsar, for example, rotates about 11 times per second. Played through a speaker, its signal becomes a rapid series of clicks, almost like the flutter of a distant helicopter's rotor or the steady roll of a drum. Even faster is the pulsar at the heart of the Crab Nebula, the remnant of a supernova observed by astronomers on Earth nearly 1,000 years ago. That young pulsar spins roughly 30 times each second. If you could hear its pulses, they would merge into an eerie, low tone on the threshold of human hearing, like a faint hum from deep space. And incredibly, there are pulsars even faster. Millisecond pulsars, old neutron stars, spun up by binary companions, whirling hundreds of times per second. The fastest known spins more than 700 rotations each second, a stellar humming top pushing the limits of physics. Its flash would sound like an urgent whine, far above our hearing range, were we able to directly listen. These spinning beacons are astonishingly precise. They keep time like cosmic clocks. Some pulsars are so regular that their beat hardly changes over decades. Only the gradual draining of their energy slows them, and even that happens exceedingly slowly. In fact, pulsars are used by astronomers as timing tools. The most stable ones rival atomic clocks in their consistency. It's humbling to realize a collapsed star, silently whirling in the darkness, can have a heartbeat as steady as anything in nature. Over time, we learn to decipher more about these cosmic lighthouses. A pulsar's pulse rate tells us how fast it spins. If the rhythm slows slightly, it can mean the neutron star's powerful magnetic fields are breaking it, or that it has shifted somehow, perhaps a starquake in its crust, subtly changing its rotation. Occasionally, a pulsar will suddenly speed up for an instant, a glitch, possibly caused by its superdense matter, rearranging itself internally. By listening carefully to these changes, scientists gain insight into the extreme physics at play. Through their pulses, pulsars whisper about ultra-dense matter, about gravity and magnetic fields at their most intense, about the aftermath of stellar death. One extraordinary pulsar even helped confirm subtle ripples in spacetime. In the 1970s, astronomers discovered a pulsar orbiting another neutron star, a binary pair locked in a cosmic dance. With each orbit, the pulsar's signals arrived at Earth just a bit sooner or later, wobbling as gravity tugged at the space-time between us. Over years, they found this stellar dance was slowly tightening, the two neutron stars spiraling imperceptibly closer together. It was exactly as Einstein's theory predicted if the system were radiating gravitational waves, carrying energy away. Decades before we could directly hear such gravitational waves from colliding stars, this pulsar pair had already whispered of their existence through the precise ticking of its clock-like pulses. They also serve as cosmic signposts. In fact, when humanity sent the Voyager probes out into the cosmos, aboard each was a golden plaque carrying a map of Earth's location. How was this map drawn? Using pulsars. The plaque shows several pulsars in our galaxy with their precise pulse frequencies indicated. Any distant spacefarer who finds that map and recognizes pulsars would be able to triangulate our sun's position from those distinctive cosmic beacons. We chose pulsars for this galactic map precisely because they are unique, easily recognizable, and constant across the eons. Think about that. The steady voices of dead stars have been used to mark our place in the galaxy. The very phenomenon once playfully suspected to be aliens is now our beacon to potential aliens, our way of saying, here we are, using the galaxy's own lighthouses as reference points. And just as we've used these beacons to point the way for others, we can also use them to guide ourselves. In fact, scientists have begun experimenting with pulsar navigation, using pulsars as a kind of cosmic GPS. By measuring the arrival of pulses from several known pulsars, a spacecraft far from Earth could pinpoint its own location, much like sailors in old times used the stars. Perhaps one day, future voyagers crossing the interstellar ocean will steer by these pulsing lighthouses, tuning into their steady beats to find the way home. Yet, gazing up at the night sky, of course, we cannot see the flashes of a pulsar with our eyes. Their beams might be brightest in radio waves or X-rays, not visible light. To us, the stars appear silent. But with radio ears, we now know the sky is alive with these subtle rhythms. Dozens of pulsars sweep their beams across Earth at any given moment, each one a tiny periodic blip in the background hiss of space. It's as though the cosmos has a hidden orchestra of metronomes, all ticking away quietly while we go about our lives oblivious, until we build instruments to listen. Since that first discovery, astronomers have discovered thousands of pulsars scattered across our galaxy, and even a few in neighboring galaxies. We find them in all kinds of places, nestled in clusters of ancient stars, adrift in the remnants of supernova explosions, or orbiting quietly in the galactic plane. Each pulsar has its own character. Some emit only radio waves, others also flash in X-rays, or even glimmer faintly in visible light. A handful spin alone, while others dance with companion stars. Yet despite their differences, all pulsars share the same essence. A neutron star spinning in the darkness, ticking out a steady cosmic rhythm long after the star's visible life has ended. These cosmic metronomes remind us that even in death, a star can be a thing of beauty and intrigue. A pulsar is a star's afterlife, not a cold silence, but an active, whirling dance. Every pulse we catch is a reminder of a star that once shone brightly, then collapsed, but refused to go gentle into that good night. Instead, it spins on, flashing a beacon into the cosmos, perhaps for millions of years after its death, like an echo that takes ages to fade. Ever since their discovery, pulsars have captivated astronomers and the public alike. They bridge imagination and reality. Once the stuff of science fiction, a homing beacon in the stars, now an everyday reality of the universe. And yet, knowing what they are doesn't diminish their magic. If anything, it heightens it. We now comprehend that nature can create something far stranger than any fiction, a spinning, magnetized cinder of a star that signals the cosmos with lighthouse-like precision. The discovery of pulsars opened our ears to a new kind of cosmic music. But pulsars, remarkable as they are the voices of stars that have already died. What of the stars that are still living, still burning their nuclear fuel? Do they too have something to say, some hidden music of their own? It turns out they do. The cosmos is not just alive with the ticking of pulsars. If we listen closely, we can hear that even ordinary stars sing a quiet song. Stars may seem like silent, eternal lights, but beneath their serene glow lies a hidden symphony. The cosmos is not quiet at all. Even the ordinary stars are humming their own tunes. If you could somehow place an ear beside a star like our sun, ignoring the impossibility of sound in space, you might feel the star's vibrant energy thrumming. Stars are not solid, silent orbs. They are great spheres of searing gas that can quiver and ring. In fact, every star carries vibrations within it, subtle ripples that cause its surface to rise and fall ever so slightly, like the faint breathing of a giant. This idea of stellar music isn't just poetic. Over the past few decades, astronomers have learned to detect and study these gentle stellar oscillations. There is even a name for this field of study: astroseismology, literally star shaking. It's akin to listening to the ringing of a bell to deduce its composition and shape. In a similar way, by observing a star's minuscule pulsations, scientists can probe its inner structure. The sound waves that echo inside a star can reveal what the star is made of, how big it is, and how it's changing over time. How do we hear a star's song? Stars are far too distant for us to feel their vibrations directly. Instead, we watch how they flicker. As a star oscillates, it expands and contracts by tiny amounts, and this makes its light brighten and dim in rhythmic patterns. Often these brightness changes are tiny, just a few parts in a million, imperceptible without sensitive instruments, yet enough to carry the signature of the star's vibrations. Telescopes can measure these faint flickers in a star's brightness. By analyzing those patterns, we decode the frequencies at which the star is vibrating, much like picking out the notes in a chord. Our own sun was the first star whose song we carefully charted. In the 1960s, astronomers discovered that the sun's surface ripples. Although the sun looks steady to our eyes, it actually oscillates in and out by a few meters every few minutes in multiple overlapping patterns. It's as if the sun were ringing with millions of different notes all at once, a complex harmony that lasts for billions of years. If we take the sun's vibrational data and speed it up to human hearing range, the sun produces a low, rich hum, the music of our home star. We have essentially heard the sun, not through sound waves in space, but by translating its light variations into sound. It's a calming, resonant tone, like a great gong sounding in slow motion. Every star has its own unique song. Smaller, compact stars often sing at higher pitches, faster oscillations, while giant stars with bloated atmospheres sing in slower, deeper tones. Red giant stars, for example, can take days or weeks to complete one oscillation cycle, a very slow drumbeat, whereas a sun-like star might complete several pulsation cycles in a matter of minutes, producing a higher-pitched tremolo, though still far below the threshold of human hearing, without technological help. When we talk about stars singing, it's a metaphor, of course. The vibrations are actually trapped sound waves traveling inside the star's searing hot gas. These waves bounce around within the star's interior, reflecting off different layers. Some frequencies reinforce each other, forming standing wave patterns, the star's natural modes of vibration. Imagine the star as a colossal musical instrument, like an enormous organ pipe or a spherical bell. The notes it produces depend on its size, temperature, and internal composition. The result is a rich spectrum of tones. Instead of one single note, a star resonates with many frequencies at once, a celestial chorus contained in one shining orb. By studying those stellar resonances, astronomers unlock otherwise unreachable secrets. Much as geologists use earthquakes to probe Earth's interior, astrophysicists use starquakes to probe the insides of stars. The oscillations can tell us where helium turns into carbon in a star's core, or how old a star is, or whether it has a hidden companion tugging at it subtly. The pitch of a star's vibrations might reveal if the star has a dense core or a more diffuse one. The presence of certain frequencies can indicate layers within the star, like a map of its insides written in music. One of the most beautiful aspects of this stellar music is how it turned a poetic notion into tangible science. The ancient philosophers spoke of the music of the spheres, imagining that the stars and planets resonated with a kind of divine harmony. For a long time, this was thought to be merely metaphor, but now we've learned that stars truly do pulsate in concert with physical laws, creating actual, measurable rhythms. The harmony of the cosmos isn't just a romantic idea, it's real, and we can hear it with our instruments. The discovery of stellar oscillations came gradually. Variable stars have been known for centuries. stars that brighten and dim periodically. For example, by the early 20th century, astronomers knew about Cepheid variables, giant stars that swell and shrink in a regular cycle of days, their brightness oscillating along with the expansion and contraction. Those were overt, dramatic rhythms, the stars literally getting bigger and smaller. Cepheids turned out to be vital cosmic yardsticks for measuring distance across space, their steady beats helping us gauge the scale of galaxies. One famous Cepheid is Polaris, the North Star, which pulsates every few days, a reminder that even seemingly constant stars have rhythms. But beyond those obvious throbs, most stars were assumed to shine steadily. That began to change late in the 20th century. Astronomers started detecting extremely subtle brightness variations in stars, like our Sun and others, too small to notice with the naked eye, but unmistakable with precise instruments. The Sun's quiet pulsations were confirmed, and soon after, scientists found other stars with similar gentle flickers. With the advent of space telescopes in the 2000s, like the Kepler spacecraft and later TESS, the ability to monitor starlight continuously and precisely from orbit led to an explosion of stellar music being recorded. Thousands of distant suns began to reveal their hidden rhythms. Some star songs turned out to be clear and simple. For instance, certain sun-like stars present lovely, orderly patterns of oscillation, which researchers can match to theoretical models with ease. But other stars proved far more puzzling. A class of stars known as Delta Scuti stars exemplified this mystery. These are young, rapidly rotating stars, 1.5 to 2.5 times the mass of the Sun. Astronomers had long seen they pulsate, but the pulsations seemed chaotic, a jumble of many notes with no clear tune. Trying to decipher a Delta Scuti star's vibrations was like listening to an orchestra tuning up, a cacophony without resolution. For decades, the Delta Scuti stars were the unsolved riddles of stellar seismology. Scientists often joked that listening to them was like hearing a cat walk across a piano keyboard, random, discordant notes with no melody. But very recently, breakthroughs have been made. In 2020, using data from a space telescope, astronomers identified a group of 60 young Delta Scuti stars producing remarkably regular pulsation patterns. They discovered that some of these stars actually sing in harmony. It was as if those erratic piano notes suddenly arranged themselves into a pleasant tune. Researchers could, for the first time, discern a sequence of clear tones from these stars and match them to specific vibrations within the star. This discovery was like finding the key to a musical cipher. Now the once mysterious Delta Scuti stars can be understood in detail, their ages and structures determined from their rhythmic patterns. The excitement of this finding resonated through the astronomy community. It proved that even in what sounds like cosmic noise, there can be a pattern, a rhythm, if we listen with enough precision. Think of it. A star hundreds of light years away, invisible to the human eye, rotating swiftly and pulsing in complex ways, now suddenly revealing a clear, steady beat that was there all along. The chaotic became comprehensible. Cosmic music emerged from what initially sounded like static. And so, the orchestra of stars keeps growing. Each new generation of telescopes reveals more of these stellar vibrations. Through them, we've discovered that giant stars in their old age often oscillate in slow, grand swells, as if tolling a final bell. Younger, smaller stars trill with quicker, lighter notes. Even exotic objects, like white dwarfs, the embers of stars, can vibrate in ringing tones as they cool, allowing astronomers to examine their crystallizing interiors through their pulsations. For instance, one such cooling dwarf star appears to be developing a solid crystal core, essentially a gigantic diamond forming in space, a revelation made possible only by listening to its faint pulsations. In time, as telescopes improved, astronomers managed to discern faint, fuzzy halos around some pulsars and variable stars, the light of the galaxies or nebulae hosting them, overwhelmed but not entirely lost in the glare. It became clear that many cosmic phenomena we observe are not isolated. They are part of larger structures and life cycles. Having listened to the gentle music of stars, we can turn our attention even farther out and to stranger phenomena. Not all cosmic voices are as gentle or harmonic. Some are intense beacons from the distant reaches of the universe, shouting across time and space. Among these are the quasars, enigmatic, powerful objects that marked the early universe with their brilliance and still echo their energies to us today. Our journey of cosmic sound now leads us from the subtle symphony of stars to the resounding call of quasars, the voices from afar. When radio astronomers first pointed their instruments to the sky beyond our galaxy, they picked up puzzling voices from the darkness. Among the faint hiss of cosmic static, there were unexpected, intense sources of radio waves that didn't match any familiar celestial object. They appeared on the sky like dim stars, but their radio emissions were astonishingly strong. Optical telescopes showed only a point of light at those positions, almost star-like. Hence they were dubbed quasi-stellar objects. But these were no ordinary stars. They were quasars, and their discovery in the early 1960s opened a new chapter of cosmic understanding. At first, quasars were an enigma wrapped in faint starlight. In 1963, a breakthrough came from a young astronomer examining the spectrum of one bright quasi-stellar source. The pattern of lines in its light was utterly strange, not matching any known chemical signature, until he realized the truth. The lines were ordinary hydrogen, but redshifted beyond recognition. In other words, the light had been stretched to longer wavelengths by the expansion of the universe, indicating the object's incredible distance. This unassuming point of light in the sky was billions of light years away, yet somehow it shone brightly enough to be detected across that vast gulf. It was as if a single candle on the far side of Earth were visible to the naked eye, a truly mind-boggling luminosity. The term quasar comes from quasi-stellar radio source. It reflects those early observations, an object that looked star-like but poured out prodigious radio energy. As more were found, it became clear that quasars are among the most brilliant beacons in the universe. Imagine a typical galaxy, a giant collection of billions of stars. A quasar can outshine hundreds of galaxies put together. All that energy, however, originates from a region no larger than our solar system. This realization came from observing that quasars can vary in brightness over short timescales, weeks or months. Such rapid changes imply a compact source. After all, a whole galaxy cannot flicker in a month, but a small light source can. Whatever engine powered a quasar, it was confined to an incredibly small volume to produce such quick fluctuations. In time, as telescopes improved, astronomers managed to see faint, fuzzy halos around some quasars, the light of the galaxies hosting them, overwhelmed but not entirely lost in the quasar's glare. This cemented the idea that quasars are not solitary anomalies, but rather the brilliant cores of distant galaxies in upheaval. Today, we understand what that engine is: a supermassive black hole, voraciously consuming matter at the center of a young galaxy. Picture a black hole millions or even billions of times more massive than our Sun. Around it swirls a glowing disk of gas and dust, the doomed material spiraling inwards. As that material falls toward the black holes more, it is compressed and heated to extreme temperatures, radiating fiercely across the electromagnetic spectrum. The infalling gas releases gravitational energy as light, turning the darkness into a blaze. Jets of particles often erupt from the poles of this maelstrom, shooting outward at nearly the speed of light. These jets beam out radio waves and other radiation far into space. The result of all this tremendous activity is a quasar, essentially a galaxy's core lit up to spectacular intensity by its central black hole feasting on matter. And in 2019, astronomers obtained the first direct image of such a cosmic engine. They captured the dark silhouette of a supermassive black hole in the nearby galaxy M87, surrounded by the glowing ring of its hot accretion disk, concrete proof at last of the type of power source that fuels quasars. The scale of a quasar's power is difficult to fathom. The brightest quasars pour out hundreds of trillions of times more energy than the Sun. In fact, for a time in the early universe, quasars like these likely outshone the entire galaxies that hosted them. From distances of billions of light years, we see them as tiny beacons, pinpoints of light that outshine everything around them. For instance, one of the first identified quasars, called 3C273 in the constellation Virgo, is about 2.5 billion light-years away. Yet it is so luminous that under dark skies, large amateur telescopes can actually spot this quasar as a faint star-like point. Pause to consider that. Your eye, aided by a telescope, gathering photons that travelled 2.5 billion years to reach Earth, emitted by a single source so far away. It's a direct connection to a deep past, a whisper of ancient light appearing as a tiny spark in the eyepiece. The light from quasars carries with it a story from the early universe. Many quasars lived and shone brightly when the universe was much younger than it is now. The most distant quasar found to date emitted its light when the cosmos was less than 1 billion years old. Mere infancy compared to its current age of roughly 13.8 billion years. That light has been travelling for almost the entire history of the universe before ending its journey in our telescopes. In essence, looking at a quasar is like peering through a keyhole into the distant past. These objects are relics of a time when galaxies were forming and black holes were devouring gas at furious rates. Not only do quasars allow us to witness the early cosmos, they also illuminate the intervening space. As quasar light journeys across billions of light years, it passes through clouds of intergalactic gas and dust. Every time it encounters atoms in its path, certain wavelengths of the quasar's light are absorbed, leaving telltale fingerprints in the spectrum. By studying those faint absorption lines, astronomers can learn about the composition and state of the gas in the forgotten corners of the universe, gas that would otherwise be invisible. In this way, quasars act like cosmic lighthouses, their beams probing the darkness and revealing the presence of things in between. We have detected, for example, the spectral imprints of primordial hydrogen clouds, and even the shadows of early galaxies in quasar light. They have helped map the distribution of matter across cosmic scales, a feat no single star could accomplish. If the gentle oscillations of stars are like a symphony, a quasar is like a soloist performing a cosmic aria at full volume. There is subtlety and information encoded in that powerful light. Quasars often have a distinctive voice when converted to other formats as well. Radio telescopes, for example, can listen to the radio frequencies emitted by quasar jets. When these signals are transformed into sound, a process similar to what we do with pulsars, a quasar might sound like a persistent hiss or roar, the audio analogue of its immense energy output. Of course, unlike pulsars, there's no regular beat or pulse to a quasar's emission. It's more of a continuous blast of noise from an energetic furnace. That being said, quasars can and do vary, sometimes flaring up or quieting down in unpredictable ways as the black hole's feeding rate changes or magnetic fields reconfigure. In a sense, they do have a kind of rhythm, but it's a tumultuous, irregular one. The chaotic roar of a bonfire that occasionally crackles and pops, rather than the steady ticking of a clock. The discovery and understanding of quasars significantly changed our perspective on the universe. It showed that even seemingly empty space in the far reaches of the cosmos could produce phenomena of astonishing power. In the 1960s, when the first quasars were identified, the idea of black holes was still theoretical and exotic. Yet here was evidence that not only did they exist, but they could grow to gargantuan scales and profoundly affect their surroundings. In the cores of young galaxies, these supermassive black holes acted like cosmic engines, pumping energy into space. Quasars likely influenced the evolution of their host galaxies. The flood of radiation and fast winds from the quasar could blow away gas, perhaps shutting down star formation in the galaxy after a period of prolific activity. In effect, quasars might be a galaxy's way of burning brightly and then cleaning up, marking the end of its wild youth. Over the decades, thousands of quasars have been catalogued. We see them scattered across the sky, each one a beacon from a distant era. Some are relatively nearby, cosmically speaking, and comparatively less luminous. Others are at the very edge of the observable universe, tiny flickers of light from the dawn of time. We've even found entire clusters of quasars, suggesting that in some regions of the early universe, supermassive black holes were numerous and active all at once. Quasars also come in different flavors. A quasar viewed from straight on, with its jet aimed toward us, appears a bit different, often called a blazar, and may show rapid variability and even higher apparent intensity due to our viewing angle. Others might be shrouded in dust or gas, such that we mainly see their powerful infrared glow. But at their heart, all these active galactic nuclei, quasars, blazars, radio galaxies, are the same phenomenon viewed from different angles or in different stages. A supermassive black hole engine, devouring matter and shouting its presence across the cosmos. From a human perspective, quasars are almost metaphysical in their extremes. They challenge our sense of scale and power. We often describe nature's sounds in gentle terms. The whisper of wind, the song of whales, the quietude of stars, as we've heard. But here we have something that truly merits a louder descriptor, a cosmic shout from billions of years ago. And yet, by the time that shout reaches us, stretched by eons of travel and expansion, it arrives as a faint signal, a whisper of a shout, in a way. Our instruments strain to detect it, to pull it out from the background noise. When we finally do, we unveil the story of a colossal black hole consuming matter with ferocious intensity in the young universe. In the grand tapestry of cosmic communication, quasars represent the bold, dramatic passages, the fortissimo movements in the music of the cosmos. They contrast with the softer, steadier voices of pulsars or the delicate melodies of oscillating stars. Together, all these signals paint a portrait of a universe alive with activity, from the smallest starquakes to the blazing heralds of creation in distant galaxies. As we end our exploration of quasars, those distant voices from the dawn of time, we prepare to shift our attention once again, this time to the whispers that emerge when stars reach the end of their lives. Not all cosmic messages come from ongoing processes. Some arrive at the moment of transformation, when a star changes form or dies. In the final chapter of this journey, we will listen to what stars say as they fade or explode, when they whisper goodbye to the cosmos. Every star knows its own kind of farewell. Some go quietly, shedding their outer layers into space in a slow, beautiful release. Others go out in a final flash of glory, a supernova that momentarily outshines whole galaxies. And sometimes, before the grand finale, a star offers only the gentlest hint that the end is near, a soft whisper before the silence. For centuries, sky watchers were baffled by a star in Cetus that would vanish and then reappear. Early astronomers named it Mira, Latin for wonderful or astonishing, because of this strange behavior. We now know Mira is a dying red giant star, one that pulsates in brightness over about 11 months. With each pulsation, Mira expands and contracts, its surface cooling and warming. In those throes, it gently breathes out its atmosphere. If you could watch in time-lapse, you'd see shells of gas drifting away from Mira, forming a pale cocoon that will eventually become a planetary nebula, the star's gossamer remains spread across light years. In fact, one of the most famous planetary nebulas visible in our sky, the Ring Nebula in Lyra, is a delicate cloud of gas cast off by a dying star, much like Mira. Mira's rhythmic brightening and dimming is the star's way of whispering goodbye. Each cycle, a soft sigh of matter released to the cosmos. Our own sun is destined for a similar fate far in the future. It, too, will become a red giant and pulsate, casting off its outer layers in successive waves. In its final millennia, the sun's light may flicker slightly as it gives up its substance to the surrounding space, crafting a faint halo of glowing gas that will mark its departure. That husk of a star, a hot white dwarf at the center of an expanding luminous veil, will be the sun's quiet memorial in its death. Future astronomers, billions of years hence, might gaze at the delicate shell of the solar nebula and read in it the final whispers of our star. Massive stars, on the other hand, tend to go out with a bang, but even they have their subtle farewells. Before a star, many times, the sun's mass explodes as a supernova. Its core undergoes profound changes. In the last moments, the core collapses catastrophically, and temperatures soar to billions of degrees. Subatomic reactions flood the core with ghostly particles called neutrinos. These neutrinos rarely interact with matter. They slip through whole planets as if they were empty space. Yet a collapsing star core produces such an enormous swarm that for a few seconds the star outshines the entire universe in neutrinos. This burst of neutrinos is essentially the star's death announcement, a last energetic exhalation from its collapsing heart. Remarkably, we have caught this whisper from a dying star. In late February 1987, deep in an underground laboratory in Japan, large tanks of fluid began to register tiny flashes of light, signs that neutrinos had barreled through and occasionally collided with atomic nuclei. Around the same time, neutrino detectors in the United States and Russia also recorded unusual bursts. For a few precious seconds, the instruments sensed something out of the ordinary. Over 24 neutrinos arriving almost simultaneously, far above the normal background level. Just hours later, astronomers in Chile reported a new bright star in the Large Magellanic Cloud, a nearby dwarf galaxy. A massive star there had exploded, the nearest supernova seen in nearly 4 centuries, now known as supernova 1987a. Those neutrinos were the star's final whisper, escaping from its core in the instants before the outer layers blew apart. By the time the brilliant flash of the supernova reached Earth, the neutrinos, traveling at near light speed and unimpeded by the star's outer layers, had already arrived and given us the news. It was as if the star said, in an almost undetectable murmur, "I'm about to go." And then, with the supernova's light, it was gone. Supernova 1987 taught us just how much information lies in these silent goodbyes. The neutrino signal arrived roughly 3 hours before the visible light, providing crucial confirmation of theories about what happens when a star dies. We learned that most of the energy of a supernova, a staggering amount, is released in the form of neutrinos, not light. And because we managed to listen to this neutrino whisper, we gleaned details about the collapsing core, its density, the newborn neutron star forming at its center, that we could never have inferred from the light of the explosion alone. Not all prelude whispers are so fleeting or so faint. In some cases, astronomers have observed massive stars engaging in a kind of erratic behavior in the months or years before they explode. Some giant stars cast off large eruptions of gas or fluctuate wildly in brightness, as if struggling through convulsions in their final acts. One could imagine it as a sort of death rattle, the star trying to stabilize and then finally giving in to collapse. In 2013, for example, a luminous star in a distant galaxy was seen to brighten unexpectedly and shed a shell of material. Just a short time later, that same star ended its life in a supernova blast. It's as though the star cleared its throat with one last outburst before the end. These preliminary murmurs are helping astronomers recognize stars on the brink of death, potentially allowing us to catch the next galactic supernova in the act. The voices of dying stars come in many forms. We've spoken of light and neutrinos, but there are other messengers too. When the most massive stars of all collapse, they sometimes form a black hole instantaneously. In that violent birth of a black hole, the infalling matter's sudden halt can create a burst of gravitational waves, ripples in the fabric of space-time itself. These waves race outward at light speed, similar to how neutrinos do, unfettered by any intervening matter. In principle, they carry a detailed imprint of the star's final moments. In practice, they are incredibly hard to detect. By the time they reach us, they cause only the tiniest tremble in space, far smaller than an atom. But modern observatories have begun to measure these minute distortions. In 2017, the LIGO and Virgo gravitational wave detectors sensed a faint, fleeting signal that turned out to be the death spiral of two neutron stars merging. Over the course of about 100 seconds, those dead stars, remnants of earlier supernovae, danced closer and closer, radiating gravitational waves that gradually increased in pitch and intensity. When translated into sound, it was literally a chirp, a quick rise in tone that abruptly cut off as the two neutron stars collided and likely formed a black hole. That final chirp was the whisper of a stellar goodbye on a very different stage. Two stellar corpses saying farewell as they became one. And accompanying that chirp, telescopes caught a brief flash of gamma rays and a glow of explosive debris, confirming the event. For the first time, humanity both heard and saw a cosmic cataclysm through two different channels. The merging neutron stars produce not only gravitational waves, but also light and other radiation, a cosmic fireworks display to go with the faint ringing of space-time. This landmark event announced a new era of astronomy, one where we use multiple senses, so to speak, to witness the universe's most dramatic moments. Gravitational waves from collapsing or colliding stars are the newest way we are learning to listen to the universe. They are difficult to detect, yes, but they carry information that light or particles cannot. They can tell us about how a star's core imploded, or how two massive objects danced in their final moments, without any light ever reaching us. In a sense, they are the purest form of a cosmic whisper, a direct disturbance in spacetime, like a message in the very geometry of the universe. Through neutrinos and gravitational waves, we now have ears tuned to the most elusive of stellar farewells. From the gentle pulsation of a red giant shedding its skin, to the ghostly neutrino burst from a collapsing core, to the subtle ring of space-time as two stellar remnants unite. Each is a chapter in the story of cosmic endings. And these endings are also beginnings. The material shed by a dying star seeds new generations of stars and planets. The neutron star left behind may later merge and give birth to heavier elements. Even the quiet nebula from a sun-like star will one day mix into the galaxy and contribute to future suns. The whispers of dying stars thus echo onward, their messages encoded in the very matter that makes up our world and our bodies. After all, the iron in our blood was forged in a supernova explosion, a star's explosive goodbye long ago, which we only know about because the universe retains the memory of that violence in the elements themselves. Our journey through the cosmos has taken us from the steady ticks of pulsars to the songs of stars and the shouts of quasars, and now to the hushed farewells of dying suns. Each cosmic signal, loud or quiet, carries meaning. As we conclude this part of our exploration, we are left with a sense of the vast conversation happening all around us in the universe, mostly unheard until recently. Beyond the signals of individual stars and galaxies lie even more ancient and mysterious messages. A faint background chorus that pervades all of space, and sudden, enigmatic bursts that still defy full explanation. The universe's story isn't finished, and neither is its symphony of whispers and shouts. In the next part, we will attune our ears to the deepest and most puzzling cosmic signals of all, the ones that have travelled across all of time, and the ones that challenge our understanding of what, or who, might be calling out across the cosmic void. To our human ears, outer space is a realm of silence. No air means no sound can travel. Yet in a different sense, the cosmos has never been truly silent. Once we learned how to listen, faint whispers began to emerge from the darkness. In the crisp morning air on a New Jersey hilltop, an enormous metal horn antenna gazed upward at the sky. This gigantic, bell-shaped receiver, about 20 feet long, looked like a giant megaphone listening to the stars. Two young astronomers stood nearby, ears literally tuned to the heavens. They were listening, waiting, and hoping to hear something meaningful beyond the static. What they heard was a quiet hiss, steady, soft, and unrelenting. At first, it seemed like just another noise, an annoyance in their experiment. But this subtle background hum refused to disappear, persisting day and night, and from every corner of the sky. Determined to find the source of the mysterious noise, the researchers checked every part of their equipment. They crawled inside the great horn-shaped antenna, expecting to find something, anything, that could explain the persistent hiss. What they found were two pigeons roosting in the antenna's belly. A layer of pigeon droppings coated the inside, a possible culprit for interference. With gentle care, they cleaned out the mess, climbing around in the metal cavern, brushing away the white dielectric material the birds had left behind. The pigeons were relocated and the antenna made pristine. For a moment, the scientists felt relief, convinced they had banished the nuisance sound. But when they pointed the antenna at the sky again and listened, the whisper was still there. The noise had not changed at all. This faint hiss was not a glitch they could scrub away, or a local interference they could avoid. It seemed to come from everywhere, all at once, uniform and soft, like a gentle wind blowing through a forest of stars. The two young men puzzled over it. Could it be something from Earth after all? Some distant earthly transmitter? They listened at different times of day and night, but it remained constant. Could it be the Milky Way itself, or some halo of radio static around our planet? They adjusted their instruments, accounting for every known source of noise. Nothing explained it. At last, they began to accept an astonishing idea. Perhaps this quiet background sound was not an error at all, but a real signal coming from the depths of space. Unbeknownst to them at first, they had stumbled onto a cosmic whisper older than any star. The year was 1964, and these two radio astronomers, Arno Penzias and Robert Wilson, had inadvertently discovered the cosmic microwave background radiation. In their careful effort to silence all noise, they had uncovered the faint afterglow of the Big Bang. This was, in fact, the very signal that cosmologists had predicted would remain from the universe's hot birth, proof of the Big Bang itself, caught by accident. That persistent hiss was the cooled echo of creation itself, still resonating through the universe nearly 14 billion years later. Once they recognized it, the realization dawned slowly. This was no ordinary star or galaxy speaking, but the universe itself, softly reminiscing about its fiery birth. The discovery left them in awe. Imagine standing in a dark, silent room and suddenly hearing the faint memory of a great explosion that happened eons ago. That was what their antenna had done. It heard the almost imperceptible reverberation of the cosmos's beginning. The noise was just a few degrees above absolute zero, a subtle warmth filling space. It had been there all along, a background murmur that every radio telescope hears if tuned right, but it remained hidden until someone paid close attention. With this revelation, a new chapter in understanding the cosmos opened. The universe wasn't silent at all. It had been quietly humming about its origins all this time. This was not the first time humanity had heard the cosmos murmur. Over 3 decades earlier, in the early 1930s, a lone engineer at Bell Laboratories had similarly pointed a curious ear toward the sky. Karl Jansky was investigating annoying static that disrupted radio communications. He built a peculiar rotating antenna in a field, a contraption of wooden beams and wires mounted on old Model T car wheels. Day after day, he recorded crackles and hisses from thunderstorms near and far. But amid that cacophony, he caught something else. A faint, steady hiss that he could not explain. It wasn't lightning, and it wasn't any known human-made signal. Intrigued, Jansky observed this mystery static carefully as his antenna slowly turned like a merry-go-round scanning the horizon. On long evenings, Jansky would sit in a small wooden shack beside his rotating antenna, headphones on, listening intently. The crackle of distant storms would fade in and out, and through it all, that faint cosmic hiss persisted. In the darkness of the New Jersey fields, with cricket song around him, he was essentially hearing the voice of the Milky Way without yet knowing it. Night after night, the mysterious static rose and fell with a steady rhythm, never ceasing to pique his curiosity. He noticed that the unknown hiss rose and fell each day, but not on the schedule of the sun or any earthly day. Instead, the signal peaked about 4 minutes earlier each successive day. To an astronomer, 4 minutes is the difference between the solar day and the sidereal day, the rhythm of the stars. This was a clue. It meant the source of the hiss was fixed in the sky, tied to the stars rather than the sun. Following this clue, Jansky tracked where the signal was strongest. In 1932, he finally pinpointed the origin. It was coming from the heart of our Milky Way, near the constellation Sagittarius. The center of our galaxy was whispering in radio waves, sending out a gentle hiss across space. When Jansky revealed his findings in 1933, few could grasp the significance. Astronomy had always relied on light and photographs. The notion of a message in radio waves from space was completely foreign. To most people, it was astonishing enough that anything up in the sky emitted radio waves at all. The idea was new and strange. Jansky himself called it star noise, a fitting name for a sound from the stars. His discovery marked the birth of radio astronomy, a whole new way to observe the universe. If our eyes were blind to it, our radio ears could now hear a hidden cosmos singing on invisible frequencies. It was as if an entirely new sense had awakened. Where once the night seemed quiet and still, now there was a chorus of signals, previously unheard, rising from the dark. Jansky's faint galactic hiss, and later the cosmic background hum found by Penzias and Wilson, taught us that the cosmos has been speaking all along in a language of radio waves and microwaves. The sky above, which to our unaided senses seems so still, is actually alive with soft music, be it the afterglow of creation or the diffuse murmur of distant stars. These early discoveries were humbling and exhilarating. Each whisper we detected hinted at a vast source. One, the very birth of the universe. The other, the monstrous center of our galaxy. What other whispers might be out there, waiting for us to listen carefully? Our curiosity was piqued. With each new signal, we became more eager to tune in further, to sift through the static for more cosmic voices. By the mid-20th century, as radio dishes sprouted across mountaintops and deserts, we began listening in earnest. We listened not just for grand, diffuse murmurs like background radiation, but for distinct voices in the dark, specific, telling signals that could reveal new phenomena. And indeed, one cold evening, a few years after the discovery of the cosmic background, a young graduate student in England noticed something strange on a chart recording. It looked like a bit of scruff, a tiny anomaly in a sea of data. She almost dismissed it, but fate had other plans. The cosmos was about to whisper again, this time in a more rhythmic voice. The data recorder's paper scroll unwound slowly, a pen sketching the ups and downs of distant radio noise. In Cambridge, under the cold, clear skies of 1967, that young student kept a diligent watch on those squiggly lines. She had helped build a vast antenna array in a nearby field, a forest of wooden posts and wires spanning many acres, designed to catch the faint twinkling of distant quasars. Day after day, the telescope's chart recorder spilled out meters of paper, and she dutifully examined those plots by hand, eyes sharp for any anomaly. Night after night, the apparatus recorded the sky's invisible murmurs. Most of it was familiar noise or expected signals. But one evening, a tiny deviation caught her eye. A bit of scruff, as she called it, a tiny blip that didn't fit. It was so small and unassuming she nearly moved on. But something made her pause. What if this little anomaly was more than an instrument hiccup? What if the universe was whispering a secret through that little wiggle of ink? Curiosity piqued. She marked the spot on the endless roll of paper and returned to it the next day. She tuned the telescope back to that same patch of sky, and there it was again. Her heart jumped at the sight. This was no fluke, no stray noise. The signal came in a steady pattern, a series of pulses like a heartbeat echoing from across the galaxy. Each pulse arrived about 1 1/3 seconds apart, as regular as a ticking clock. The young scientist could hardly believe her eyes. This was no random noise. It was as if someone out in the dark was sending a rhythmic beacon, a cosmic metronome counting time. She double-checked everything, suspecting perhaps a stray radio transmitter on Earth or a satellite could be mimicking a star's voice. But the pattern remained, and always aligned with the same spot among the stars. In fact, each night the pulses arrived about 4 minutes earlier than the night before. Exactly the shift one would expect from a faraway star, not any earthly source. Whatever its origin, it was far beyond our planet. In the following weeks, she watched the mysterious pulses carefully. The source was small and pinpointed, a single location among the stars. If it were an intelligent signal, what could it mean? A greeting? A beacon? The notion was both thrilling and unsettling. Even the student's supervisor and colleagues, upon seeing the data, were tempted to consider an extraterrestrial sender. In jest, they labelled the source LGM-1 for Little Green Men 1, a nod to the fanciful idea that perhaps we had stumbled upon a message from an alien civilization. It was a half-serious joke, born out of the sheer puzzlement this signal provoked. After all, what natural object could pulse so precisely, so reliably, like a celestial clock ticking in the void? As the winter of 1967 turned to 1968, the investigation intensified. If this was truly a phenomenon beyond Earth, there might be more than one. The team expanded their search, pointing the antennas elsewhere. Soon, to their astonishment, they found a second signal, pulsing at a different rate from another part of the sky. This one was slightly slower, but just as steady and clear. Little Green Men 2, they joked. But the truth was becoming clear. The chances of 2 separate alien beacons appearing almost simultaneously were beyond remote. The simplest explanation was that these were natural after all, an entirely new kind of cosmic object speaking to us through these blips of radio energy. Relieved, and perhaps a touch wistful, the astronomers let go of the alien hypothesis. For a moment, Jocelyn felt a pang of disappointment that it wasn't little green beings on the line, but also a growing excitement at what it actually was. But what they found was no less wondrous. They had discovered pulsars, short for pulsating radio stars, the rapidly spinning remains of massive stars that had exploded long ago. In fact, one pulsar was later found beaming at the core of the Crab Nebula, the very remnant of a supernova recorded by astronomers in 1054 AD, direct evidence that these signals were echoes of stellar death. The young graduate student, Jocelyn Bell, and her colleagues had unveiled a cosmic marvel. These pulsars were tiny, dense stars, only a dozen miles across, yet heavier than our Sun, left behind after supernova explosions. They rotated at incredible speeds, and with each turn, they swept beams of radio waves across space. Like lighthouses on a cosmic shore, they blinked in perfect rhythm. The first pulsar she found was spinning so fast that it sent a flash every 1.33 seconds without fail, as if keeping cosmic time. Word of the discovery spread, and the scientific world was exhilarated. Here was a cosmic heartbeat that we could actually hear across vast distances. It was a sound, neither voice nor music, but a steady pulse from a dying star's core. Once scientists understood what it was, the fear or hope of alien contact gave way to admiration for nature's own beacons. This first pulsar was eventually given a less whimsical name, but the nickname LGM-1 lingered as a reminder of those initial musings about alien life. Jocelyn Bell, only a graduate student at the time, had opened humanity's ears to one of the universe's most intriguing phenomena. With more research, dozens of pulsars soon came to light, each with its own tempo, some slower, some astonishingly faster, spinning hundreds of times per second. Each pulsar was unique, but all shared the same nature. They were cosmic timekeepers, remnants of violent stellar deaths that now lived on as calm, predictable beacons. The discovery of pulsars was a testament to how the universe can surprise us. A signal that once made us wonder about extraterrestrial civilizations turned out instead to be a window into the life cycle of stars. The cosmos had more imagination than we had thought. It found a way to use the husks of dead stars to send out a steady rhythm, as if to say that even in death, a star's story wasn't over. It continued to speak, across thousands of light years, to any species curious enough to listen. After the excitement settled, one thing became clear. The universe was far from quiet or monotonous. It was teeming with a variety of signals, each revealing something new. Some whispers came from the largest scales, a faint glow filling all of space from the universe's beginning, while others came from tiny objects like neutron stars ticking away in the dark. Pulsars, with their gentle, steady ticking, told of extreme physics, of matter crushed to densities beyond imagination, of magnetic fields billions of times stronger than Earth's, of the last embers of stars flashing their lights in the darkness. And there would be more. Not all cosmic whispers were so regular and comforting. Some would come as sudden bursts, unpredictable and rare, leaving us to puzzle over their origin. Indeed, as the decades went on, astronomers continued to encounter signals that sparked new mysteries, and with them, new wonder. One particularly vivid mystery was about to present itself in the late 1970s, in the form of a brief shout from the cosmos that to this day has not been fully explained. Late on a warm August night in 1977, a giant ear was listening to the sky. This ear was the Big Ear radio telescope in Ohio, aptly nicknamed Big Ear, a vast metal antenna structure silently scanning the stars for anything unusual. For years, it had heard mostly the typical cosmic static and faint natural whispers. But on this particular night, as the telescope swept its gaze across the constellation Sagittarius, something extraordinary arrived. In the control room, a line printer chattered, spitting out columns of numbers representing the signals being received. Amid the dull stream of data, one sequence of numbers suddenly spiked off the charts. A powerful, focused burst of radio waves unlike any background noise. An astonished astronomer circling the printout saw this huge spike, and in a mix of excitement and disbelief, grabbed a pen. He scribbled one word in the margin beside the data. Wow. The signal was intense and narrow, centered at about 1420 megahertz, the signature frequency of hydrogen, the most common element in the universe. This was exactly the kind of frequency some had speculated an alien civilization might use to send a call, knowing that hydrogen's emission line is like a universal beacon. It lasted for a full 70 seconds, rising and falling as the telescope's stationary beam swept past its source. Then it was gone. Excitement bubbled up. Could this be it? The moment we finally heard another civilization's voice across the cosmic void. The news quietly spread among the small community of astronomers involved in the search for extraterrestrial intelligence. They had been listening for years for just such a beacon. Something strong, unusual, and coming from the stars, rather than any earthly transmitter. And here it was, seemingly dropped into their laps from the darkness, a beacon that said, without words, "I am here." In the days, months, and even years that followed, they repeatedly turned their instruments toward that patch of sky, eager to hear the wow signal once more. But space had fallen silent again. The mysterious transmission, if that is what it was, did not repeat. It was a one-time wonder, a solitary shout in the night that left nothing but questions behind. Scientists checked and rechecked their equipment, scoured the records for any mundane explanation. Could it have been a glitch? A passing satellite? A secret military broadcast bouncing oddly through space? Each possibility was examined and found wanting. The signal had the hallmark of coming from deep space, far beyond our solar system, perhaps even outside our galaxy. And yet, without a repeat, it was impossible to confirm exactly what had happened. The wow signal, as it came to be known, became legend. It encapsulated the hopes and frustrations of the search for cosmic company. It was as if someone out there had lit a brilliant flare and then swiftly doused it, leaving us wondering if we imagined it all. Over the years, scientists proposed various theories. Some thought perhaps a comet passing by might have emitted the unusual radio burst, or that an undiscovered natural radio source just happened to line up with the telescope's path that night. Others held on to the more tantalizing idea. Maybe it really was an intentional signal, a cosmic greeting from an intelligence that, by chance or design, we caught only briefly. To this day, no consensus exists. The sky around Sagittarius has been listened to again and again with better equipment, but the wow has not returned. No one can say for sure what the wow signal truly was, but the mere chance that it could have been a call from another intelligence sends a shiver of wonder through us. If an alien mind were behind that transmission, what might they have been trying to say? Perhaps it was a friendly greeting that traversed countless light years before brushing past our little world. Or it could have been a beacon, a stray signal from distant technology that we happened to overhear for a brief moment. The truth remains elusive, and that very uncertainty is strangely enchanting. A single, tantalizing question mark in the cosmic silence, reminding us how much we still don't know about what or who might be out there. By the late 1970s, humanity had officially entered the era of actively listening for voices from other worlds. In fact, as early as 1960, a lone astronomer had aimed a radio dish at nearby stars in a pioneering trial, listening for any peep from an extraterrestrial transmitter. That early attempt, dubbed Project Ozma, heard only silence, but it marked the quiet beginning of this quest. The project in Ohio was one of several quietly scanning the heavens for patterns or messages that nature alone wouldn't produce. Radio telescopes were aimed at nearby stars, tuned delicately to catch a whisper of technology across light years. Most nights yielded nothing but the soft hiss of cosmic noise and the familiar signals of quasars and pulsars. But the astronomers did not despair at the silence. They knew the quest could be long. The wow signal had been a lightning bolt of possibility, renewing their resolve. If there was even a chance that we had glimpsed another civilization's beacon, then continuing to listen was more important than ever. It felt as if the universe had answered a knock on the door with a single, tantalizing syllable, then gone quiet, leaving us to wonder. And so the listening continued, year after year, into the 1980s, 1990s, and beyond. With each passing decade, our ears grew sharper. More powerful radio dishes and arrays scanned the sky, covering more stars and more frequencies all at once. Back at desks and observatories, scientists pored over mountains of data, looking for that rare spark amid the noise. A few times, computers flagged interesting signals, triggering brief excitement. But each time, closer scrutiny revealed human-made interference or natural cosmic imposters. The whispers from the unknown, if any intelligences were sending them, remained elusive. Some nights, the silence felt lonely, a reminder of how isolated we may be. Yet on other nights, it felt serene and full of potential, as if the stars themselves were listening with us. The great silence that physicist Enrico Fermi once pondered, "Where is everybody?" seemed to continue. And yet, within that silence, the wow signal stood as a lonely reminder that perhaps, just perhaps, the cosmic choir had more singers waiting to be heard. Even without confirmation of alien voices, the act of listening taught us much. It forced us to reckon with the vastness and quiet of space, and with our own hopes and fears about being alone. Every quiet night of scanning the sky was a meditation on our place in the cosmos. It was humbling to realize that if someone out there was trying to speak, we might simply not understand their language, or might be missing them by a heartbeat or a hearts on the dial. Still, the search goes on, powered by the human urge to connect. All the while, the universe continued to surprise us in other ways. Because even as we listened for deliberate messages, we began to stumble upon new, unanticipated cosmic signals. Signals that were not the voices of aliens, but the voices of the universe itself, crying out in sudden bursts. Decades after the wow, as a new century dawned, astronomers would detect explosive flashes of radio energy that made the wow signal seem almost gentle by comparison, and sparked a fresh mystery to probe. It began quietly, as many cosmic mysteries do. In the summer of 2007, an astronomer sifting through old radio observations stumbled upon a puzzling signal hidden in the data. It was a single, blazing flash of radio energy that had erupted and faded in the blink of an eye back in 2001. In that split second, it had unleashed as much energy as the sun emits in a whole day. Yet it was over almost before anyone knew it happened, detected only years later in the recorded data. At first, the astronomer could hardly believe it. Was this a real cosmic event, or just a glitch? The signal was so brief and so intense that it didn't resemble anything seen before. It seemed to come from nowhere and disappeared just as suddenly, a solitary clap in the emptiness. When the discovery was announced, it sent ripples of excitement and skepticism through the scientific community. Such a burst was entirely unexpected. Some wondered if it was just an odd bit of interference, perhaps a stray radar ping, or even a microwave oven door opened at the wrong moment near the observatory. Indeed, at one Australian telescope, a series of mysterious bursts was later traced to something as ordinary as a microwave oven in the staff kitchen. An amusing reminder that not every strange signal comes from the stars. For a time, these odd signals were dubbed fast radio bursts, or FRBs, and considered curiosities. After all, only one had been found by 2007. Without more examples, it was hard to even guess at their origin. But the universe did not keep us waiting forever. In the years that followed, more of these sudden flashes were spotted in new observations. Each time, they appeared as a loud but fleeting whisper from far beyond our galaxy. Their brevity made them elusive. Blink and you'd miss them. But as technology improved, astronomers began catching them live. One by one, the fast radio bursts piled up, turning a singular oddity into a new class of cosmic phenomenon. Over the next decade, what began as a single anomaly turned into dozens of detections, and eventually many more, as new telescopes joined the search. Some were discovered in real time by telescopes scanning wide swaths of sky. With each detection, patterns began to emerge. These bursts were coming from all over the sky, which meant they were likely from distant galaxies spread across the universe. By analyzing how the radio waves were stretched or delayed as they traveled, scientists realized these signals had traversed billions of light years through intergalactic space. In other words, these bursts began their journey long before humans even existed, and only now, after traveling for eons, did they sweep past our planet. Whatever could create such brilliant flashes must be incredibly powerful. Ideas poured forth, perhaps colliding neutron stars, or the final cry of a star being swallowed by a black hole, or massive flares from magnetars, neutron stars with ultra-strong magnetic fields. Each of these possibilities inspires awe. Picture, for instance, two city-sized neutron stars locked in a death spiral, orbiting each other for eons until they finally collide in one last catastrophic embrace. The moment they merge, an enormous pulse of energy is released, perhaps enough to be seen as a split-second flash of radio waves across the cosmos. Or imagine a magnetar, a neutron star with an unimaginably strong magnetic field, suddenly cracking its own crust in a starquake. In that instant, it could emit a burst of radiation that outshines entire galaxies for a heartbeat. Even a black hole gulping down a dying star might send a brief shout of energy as a kind of cosmic farewell. These are the kinds of extraordinary events that astronomers suspect could be behind the fast radio bursts. For a while, fast radio bursts were one of astronomy's greatest puzzles. Telescopes worldwide kept ears open for them, and gradually a few began to repeat. One FRB in particular was heard again and again, sporadically flashing from a tiny galaxy billions of light years away. This repeating burst let researchers pinpoint its home, a faint dwarf galaxy, and there, a persistent source of weaker radio hum that might be the aftermath of a stellar cataclysm. The fact that some bursts repeat while others flare just once only deepened the mystery. It was as if some cosmic fires crackled with many sparks, while others gave a single pop and then went silent. We were witnesses to dramas unfolding in distant galaxies, and yet we saw only the briefest glimpse, a millisecond strobe of radio light, leaving us to guess at the story behind it. Then, a breakthrough arrived from our own cosmic backyard. In 2020, for the first time, a fast radio burst was detected, originating from within our own Milky Way galaxy. A magnetar, a highly magnetized neutron star, had produced a burst that, when measured, looked strikingly like the extragalactic FRBs. It was a cosmic clue at last. Magnetars were known to be volatile, capable of star-quaking flares and X-ray flashes, and now it seemed they could indeed emit the kind of radio burst we had been chasing across the universe. Magnetars were known to be volatile, capable of star-quaking flares and X-ray flashes, and now it seemed they could indeed emit the kind of radio burst we had been chasing across the universe. This discovery was like hearing a familiar voice in a mysterious chorus. It didn't explain every burst we'd heard, but it showed at least one instrument in the orchestra. Likely, many FRBs are born from such violent moments, starquakes or collisions in far-off galaxies that release tremendous energy. Even with that clue, much about fast radio bursts remains unknown. They remind us that the cosmos still guards many secrets. Each new burst that our telescopes catch could be the herald of some distant disaster or transformation. Perhaps two neutron stars merging into a black hole with a final shout, or a young magnetar cracking open its crust in a magnetic tantrum. With every detection, astronomers piece together a bit more of the puzzle, measuring how these signals pass through the sparse gas between galaxies, using them as tools to probe the unseen cosmic web. Bit by bit, the once baffling phenomena start to make a little more sense. Yet, a sense of enigma persists. There is a thrill in knowing that at any moment, without warning, the sky could light up with a new burst, and we might learn something completely unexpected. Now, as we reflect on all these whispers and shouts from the universe, a profound realization sets in. The cosmos is alive with communication, just not in the way we first imagined. It's not a single message or a lone voice, but a tapestry of natural transmissions. We've heard the afterglow of the Big Bang gently humming in every direction. We've caught the rhythmic ticking of pulsars, stellar remnants beating like cosmic hearts. We've captured a solitary wow that teased us with the possibility of other intellects. And we've been startled by fast radio bursts, the fleeting alarms of distant cosmic events. Each signal is a piece of the cosmic symphony, one instrument in an orchestra that spans the whole universe. These discoveries have changed how we perceive the silence of space. What once seemed an empty void now appears rich with subtle sound. The more we listen, the more we realize that our galaxy, and all the galaxies beyond, are not isolated, mute islands. They are part of a grand cosmic chorus, harmonizing in radio waves, X-rays, gamma rays, and even in gravitational vibrations. It is a music that has been playing for eons. We are only just now becoming aware of the melody. And among these myriad voices, even the darkest entities, like black holes, have their own whispers to contribute. The fabric of space-time itself can ripple and ring, carrying messages in a form entirely different from light or radio. We stand at the threshold of hearing a fuller range of the universe's symphony, from the faintest murmur left by creation's birth to the sharp crack of a star's demise, from steady stellar heartbeats to singular unexplained signals. We have begun to piece together the cosmic score. Yet so much remains to be heard. As our instruments grow more sensitive and our minds more attuned, we continue our journey of cosmic eavesdropping. As we continue this cosmic exploration, our ears will open even wider. We will listen to the combined choir of galaxies singing together, and to the deep, low tones of black holes murmuring in the dark. We will ride the gentle ripples in the cosmic sea and experiment with entirely new ways of listening to the universe. The concert is far from over. In fact, it feels like it's only just beginning. In the decades before 1977, radio astronomy had transformed how we listened to the sky. Scientists had discovered bright signals from atoms and distant galaxies, and even the steady pulse of spinning neutron stars. The first attempt to find intelligent signals came with Project Ozma in 1960. Dr. Frank Drake pointed a radio dish toward two nearby sun-like stars, hoping for a sign of company in the cosmos. He heard only silence, but the search was just beginning. Dr. Frank Drake pointed a radio dish toward two nearby sun-like stars, hoping for a sign of company in the cosmos. He heard only silence, but the search was just beginning. It was a quiet, clear night in Green Bank, Ohio. The Big Ear telescope, a massive, twin-horn instrument, stood like a gentle giant under the starry sky. Inside the observatory, the only sounds were the low hum of equipment and the scratch of printout on paper. Astronomers usually expected these machines to record distant galaxies or the faint hiss of our Milky Way. Instead, that night they found something much stranger. The idea was simple. Hydrogen is the most abundant element, and its natural radio emission should be heard by anyone who listens. If an intelligent civilization wanted to send a clear greeting, they might broadcast at that very frequency, knowing others across the galaxy would tune in. So in August 1977, Ohio State University's Big Ear radio telescope scanned a swath of sky with eager anticipation. Astronomers set their instruments to catch any unusual whisper, prepared for everything, except perhaps how astonished they would be when the unexpected finally arrived. Jerry Amon could hardly believe his eyes. The spike on the printout was unlike anything he had seen. He immediately flagged the result, circling it in red. His colleagues were called in, half asleep and skeptical. Together they double-checked the reading from every angle. For a moment they wondered if it could truly be a message from beyond Earth. The thought was thrilling and unsettling. They spent hours poring over the data. The signal's profile was clear and bright, too significant to ignore. Yet they remained cautious, logging every detail for future analysis and trying to explain the puzzling result. Astronomer Jerry Amon at Ohio State University's Big Ear radio telescope was the one listening that night. He had trained the enormous dish to scan a patch of sky for any unusual signal. Hours into the recording, an unexpected pattern stood out. Numbers and letters, 6EQUJ5, glowed in the data. Marking it in red ink, Amon wrote, "Wow," in the margin. It was a simple exclamation for a very strange discovery. The writing in the margin was more than wonder. It was truth. For 72 seconds, Big Ear recorded a strong, narrow-band signal, far brighter than anything in the cosmic background noise. Its frequency was tantalizingly close to the natural emission line of hydrogen, the simplest and most abundant atom in the universe. This led to whispers of possibility. Maybe an intelligent signal deliberately chose this universal frequency. But after that first burst, the signal was never heard again. After that unforgettable moment, the sky fell silent again. Astronomers repeatedly turned Big Ear and other instruments back toward the source. They scanned for hours, days, even years, hoping the signal would return. But the cosmos offered no second hello. That strange, brilliant blip remained a single, isolated event. Its origin is still a mystery, like a whisper that vanished into the night. The wow signal ignited imaginations. What if it were a greeting from another civilization? Yet scientists exercised caution. They understood how Big Ear recorded the sky. As Earth turned, a fixed telescope would dwell on each patch of sky briefly. A genuine signal from the stars would not linger. So by the time 72 seconds passed, the dish had moved on. In that fleeting interval, whatever it was, went silent. No pattern repeated as Earth turned away. Decades have passed without another signal like that. New telescopes and listening efforts have greatly improved our view of the universe. Yet the wow signal stands alone. Even programs dedicated to scanning the stars continue searching without finding its twin. In this way, the wow signal remains a lesson in patience. It is a reminder that the universe still hides many secrets in its vast silence, and we must keep listening to uncover them. Even now, the story of the wow signal is not the end, but only a beginning. In the years after 1977, as astronomers listened closer and farther, the cosmos revealed other whispers. Some were faster and more fleeting than the wow signal had ever been. These are the curious bursts of radio light we now call fast radio bursts. But that is a tale for our continued journey among the stars. Years after the wow signal, astronomers uncovered a different kind of cosmic whisper. In 2007, radio astronomer Duncan Lorimer and his student discovered something unexpected in old telescope data. A sudden flash of radio waves that lasted only a few milliseconds, yet was incredibly intense. They had stumbled upon the first known fast radio burst, a mysterious signal from well beyond our own galaxy. This brief, brilliant burst of radio energy became known as the Lorimer burst, opening a new chapter in cosmic radio mysteries. To find the first FRB, Duncan Lorimer was examining old data from the Parkes Radio Telescope in Australia. He found the burst serendipitously. The flash appeared on the screen as a bright signature lasting just a few thousandths of a second, almost as if a cosmic strobe light had gone off and left its mark. Lorimer recalls the moment with exhilaration. He and his team had uncovered an extraordinary signal. Thanks to its dispersion sweep, a telltale smear of radio frequencies arriving over time, they could tell it had travelled through a vast amount of space. Its source lay far outside our galaxy, making it all the more astonishing that they had captured it at all. The discovery of the Lorimer burst was just the beginning. Specialized instruments soon began capturing bursts regularly. By 2018, a new telescope called CHIME in Canada was catching dozens of FRBs every month. Other arrays, like the Australian SKA Pathfinder, ASCAP, joined the hunt. Each detection felt like finding a cosmic lightning strike. Now there are hundreds of known FRBs, each recorded in catalogues and databases. Some pulses release more energy in a millisecond than the sun does in a day. These cosmic flashes arrive at random, from unpredictable directions. With each one, astronomers learn more, but also wonder more deeply what could be causing them. One repeating FRB in particular captured scientists' attention. Known as FRB, it was detected again and again from the same patch of sky. Astronomers traced it to a dwarf galaxy about 3 billion light-years away. From that distant corner of the universe, this source flashed its radio light repeatedly. FRB 111002 acted like a cosmic lighthouse, turning on and off in an unpredictable rhythm. Its discovery proved that fast radio bursts were not just one-time flukes, but ongoing cosmic phenomena worth deeper study. Astronomers were astonished by another repeating signal. In 2020, one FRB was found to pulse on a precise schedule. Known as FRB 180916, it sends bursts in a 16-day cycle, 4 days of activity followed by 12 days of silence. This behavior suggests a cosmic clockwork, perhaps an orbiting companion or a rotating beam that only points toward us at certain times. By knowing the schedule, scientists can point telescopes proactively during the active window. This periodic FRB has opened a new chapter in the mystery, showing that the cosmos might be more regimented than we imagined. The FRB story took an even more dramatic turn in 2020. Until then, every detected burst had come from another galaxy. Then, on April 28, 2020, astronomers detected an FRB from the Milky Way itself. The source was SGR 1935 plus 2154, a magnetar only about 30,000 light-years away, essentially our galactic backyard. When it flared, radio telescopes around the world heard a pulse similar to distant FRBs. At the same time, X-ray satellites observed the same source erupting. It was as if the cosmos had handed scientists a laboratory in their own neighborhood. The power of this galactic burst was much lower than that of extragalactic FRBs, but because it was so close, it shined extraordinarily bright in our detectors. The coincidence confirmed that magnetars can indeed produce FRBs. For scientists, it was a thrilling breakthrough, a real local example proving one pathway to these cosmic sparks. Astronomers are finding that fast radio bursts are not just puzzles, but also powerful tools. As each burst travels, it crosses the universe and all the gas between galaxies. This journey leaves fingerprints on the radio waves. The lower frequencies arrive a bit later than higher ones. By studying these fingerprints, scientists can measure how much matter the waves pass through. With enough FRBs collected, we can map the otherwise invisible webs of plasma spanning the cosmos. In that way, every curious burst helps us learn not only about itself, but also about the structure of the universe as a whole. The hunt continues, with ever more powerful tools. China's fast radio telescope, with its giant 500-meter dish, is now finding especially prolific repeaters. One source in particular keeps bursting, offering chances to study a single FRB in exquisite detail. In one instance, hundreds of pulses were collected from the same object. Such treasure troves allow astronomers to analyze how the bursts vary over time, potentially revealing the hidden mechanism powering them. The technology we build for this search constantly improves our ability to listen closer. Fast radio bursts are like cosmic fireworks, dazzling and mysterious. Each one captured deepens our understanding, yet raises new questions. Astronomers wonder, are all FRBs produced by the same phenomenon, or do they have different sources? Are some bursts perhaps the footprints of collisions between neutron stars, or exotic emissions from black holes? As our global network of telescopes continues to listen, each burst is like a heartbeat from the universe, reminding us that space still has secrets to share. No matter how many we find, the central question stays: what creates these flashes? While the answer is still unclear, our curiosity has given us the gift of knowledge, and for now, the bursts encourage us to keep listening for the next flash of insight. The fast radio bursts taught us that the universe can still surprise us with new wonders. But even beyond FRBs, space is filled with other enigmatic signals and mysteries. In the radio waves and other parts of the spectrum, strange phenomena continue to appear, each hinting at stories we have yet to decipher. As our journey through the cosmos continues, we pay attention to every whisper and riddle the stars present. In 2019, a particularly tantalizing candidate appeared. The Breakthrough Listen team in Australia was quietly scanning Proxima Centauri, our nearest stellar neighbour, when they noticed a curious spike of radio energy. This detection, nicknamed BLC1, was narrow in frequency and persistent, lasting through many observations. For months, scientists wondered, could this be a message from Proxima b? But as the data piled up, the clue turned murky. The signal behaved like terrestrial interference, disappearing under scrutiny. BLC1 became a reminder of how elusive signals can be, and how careful we must be before claiming a cosmic hello. The sky continued to deliver surprises. Around 2006, astronomers found rotating radio transients, RRATs, strange neutron stars that emit sporadic radio flashes. Unlike normal pulsars that blink regularly, RRATs lie mostly silent, sneaking just a pulse here and there. Each flash is like a wink from a cosmic ghost, vanishing almost as soon as it appears. These shadowy senders suggest that countless neutron stars may lurk unseen, waiting for their turn to signal the cosmos. Their unpredictable flickers add another layer to the enigmatic chorus of space. Not all eerie space signals are extraterrestrial. For a time, observatories picked up mysterious quick bursts known as peritons, resembling cosmic flashes. A major puzzle was solved when scientists discovered that these peritons were coming from inside their own radio dish building. it turned out to be a microwave oven. A staffer was opening the door mid-cycle, and the escaping waves mimicked a cosmic burst. This episode was a humorous reminder that sometimes the strangest signals have very down-to-earth explanations. In 1967, the sky gave us one of its earliest surprises. Jocelyn Bell, a young astronomer, noticed a precise pulse of radio waves repeating every 1.33 seconds. For weeks, this beacon blinked at a distant point in space like clockwork, so regular that at first it was humorously called LGM, Little Green Men. But further study revealed the truth. It was not a hidden message, but the rhythmic heartbeat of a spinning neutron star, a pulsar. This discovery reminded astronomers that nature sometimes speaks in mysterious ways. As we examine modern enigmas, the lesson lingers. Not every signal is a secret alien call. The universe itself can create mesmerizing patterns that test our understanding. Beyond these specific blips, astronomers have listened to a more uniform whisper, the cosmic microwave background. In 1964, physicists Arno Penzias and Robert Wilson detected a faint, pervasive hiss in their radio antenna. It was confusing at first, but it soon became clear that this microwave background is the leftover glow of the Big Bang itself. This discovery wasn't a message from life, but it showed that even a steady cosmic static can carry profound meaning about the universe's origin. Listening carefully to the static revealed that the universe had a beginning, echoing a story older than our planet. The cosmos has more voices than just radio. In 2015, scientists detected ripples in spacetime itself, gravitational waves from colliding black holes. LIGO's discovery was a new way of hearing the universe. Although not electromagnetic waves, these faint reverberations echoed from over 1 billion light-years away and carried information about their cataclysmic origin. This breakthrough reminded us that space can communicate through other channels. Even as we scrutinize the radio sky, we also listen with entirely new instruments. Each tool, from radio dishes to gravitational wave detectors, broadens the dialogue between us and the cosmos. Astronomy today is truly multi-messenger. In addition to radio and gravitational waves, we observe cosmic rays and neutrinos. Giant detectors under ice or water catch ghostly neutrinos from distant explosions. Observatories record flashes of gamma rays and cosmic rays from the far reaches of space. Each of these messengers brings more puzzle pieces. Sometimes a neutrino or gamma ray will pin down an enigmatic source. The sky is telling us that it has many channels of communication. We listen to radio, but also to particles and ripples, broadening our perspective on the cosmic symphony. All these discoveries remind us how the universe still holds more questions than answers. Every strange signal, whether real or a false alarm, pushes us to refine our methods and broaden our imagination. Each unsolved phenomenon makes us tune our instruments even more finely. We carry on, eyes and ears open, ready for whatever subtle clue might next appear. The void is vast, and though it often seems silent, astronomers know it can still surprise us in countless ways. Humans haven't just listened, we've spoken too. In 1974, the Arecibo radio telescope beamed a message toward a distant star cluster. It wasn't a bid for help, but a greeting card in binary code describing our DNA and the layout of our solar system. Later, NASA's Voyager probes carried golden records containing sounds and music of Earth in case they encounter someone out there. Yet here we stand, peering out into the void, still awaiting any return message. Even as we broadcast our presence with these symbolic gestures, the cosmic radio sky remains eerily quiet. No answer has come back through the darkness so far. Astronomers have spent decades straining to hear a reply. Giant radio dishes sweep the sky. Arrays of antennas listen to every corner of the galaxy. Space agencies and research teams dedicate hours and years to sifting through data, hunting for a sign of something unusual. And yet, the question remains unanswered. Has any civilization ever truly reached out across the void? So far, no message has been confirmed as undeniably artificial. In this serene silence, all we have are our determined ears and boundless curiosity. Silence can be as telling as sound. Scientists have long wrestled with the idea behind the Fermi paradox. If the universe is so large, why haven't we heard clear voices? The Drake equation was an early attempt to estimate how many civilizations might be out there, but its factors remain uncertain. Perhaps intelligent life is extremely rare, or advanced civilizations hide their presence. As of now, the silence itself is a profound hint. It drives us to question everything. Are we looking in the right way? Could alien societies be using methods of communication we can't yet detect? The unanswered call does not frustrate us. It motivates us. It reminds us of the grand mystery. The search for cosmic companionship is about understanding the universe and our own significance within it. Yet the search itself has been its own reward. In striving to detect a distant call, we've unlocked countless cosmic mysteries. Along the way, we discovered exotic stars, learned how galaxies form, and even heard the fading echoes of the Big Bang itself. Every tool we built to catch whispers from beyond has turned up something unexpected about our universe. So even if the ultimate message remains elusive, our curiosity has given us the gift of knowledge. In the coming years, our listening will become even more sensitive. Giant projects like the Square Kilometre Array, with thousands of dishes working together, will survey the skies more deeply than ever. Telescope arrays like ALMA and FAST push the boundaries of what we can detect. In the meantime, we continue to expand our search. Tens of billions of planets have been discovered, and many more await our surveys. Astronomers study the atmospheres of distant worlds for hints of life, like oxygen, methane, or other biomarkers. Some projects even plan to detect the faint glow of city lights on exoplanets, should they exist. Every new technique gives us another way to listen and look. Across the electromagnetic spectrum, from radio waves to visible light, we train our instruments for any sign. Some scientists even watch the stars with optical telescopes, looking for brief flashes of laser light that might indicate an intentional signal. In every way, we are amplifying our ears, hoping that someday the universe might finally whisper back. We do not know what this silence ultimately means. Perhaps civilizations remain quiet by choice, or maybe communication awaits an understanding we have yet to achieve. What matters is that we keep searching. The unanswered call fills us with quiet determination. Our expedition among the stars continues, guided by endless curiosity. With each night sky we observe, the possibility remains that one day we might recognize a new voice. For now, we listen and wait, hopeful that somewhere out there, the universe may yet find a way to speak. For ages, humankind wondered if a cosmic companion might be out there among the stars. Now, at last, we have begun to truly listen for an answer. Night has fallen over the observatory, and a hush has settled across the landscape. In the stillness of a high desert night, a giant radio telescope stands under the glittering sky. Its round dish, cold and gleaming in starlight, slowly pivots to face a new patch of heavens. This silent sentinel of steel and wire is our ear to the cosmos. It gathers faint radio waves that have travelled for eons, whispering secrets from distant worlds. The surrounding mountains and plains are dark and still, save for the gentle red glow of instrument lights. Inside a nearby control room, a scientist sits in quiet focus. Through her headphones comes a faint hiss of static, the background breath of the universe. She listens intently, eyes closed, hoping that within that endless hush, a different note might sound, a signal crafted by an unknown intelligence. Half a century ago, such an idea was nothing more than science fiction. But in 1960, one young astronomer decided to try. His name was Frank Drake, and he believed that perhaps, if intelligent aliens existed, they might be sending radio signals that we could detect. In a project he dubbed Ozma, after a fairy tale queen, Drake pointed an 85-foot radio telescope in Green Bank, West Virginia, at two nearby sun-like stars. He chose a frequency around 1420 megahertz, the natural emission line of hydrogen, reasoning that if others were out there, they might also use that universal channel. Week after week, the telescope listened at that frequency, like a lonely ear pressed against the vast night. Drake heard only silence and static, and after a few months, Project Ozma ended without fanfare. Yet it was the beginning of a new quest, the first time humans reached out with instruments to eavesdrop on the stars. Others soon followed. Over the decades, more powerful ears were built around the globe. From the mountain forests of Puerto Rico to the wide plains of Australia, radio dishes large and small turned skyward. NASA even briefly funded an ambitious search program in the late 20th century, though political winds shifted and the funding was cut, leaving the work to private foundations. Still, the search pressed on. Each telescope scanned the darkness for any signal that stood out from the cosmic noise. The scientists chose their targets carefully: nearby star systems, the centers of galaxies, broad sky surveys, anywhere an artificial radio beacon might hide. Each night of listening was an act of patience and faith. The odds seemed slim. The universe is vast, and catching the right signal at the right moment is like plucking a single drop of rain from an ocean. But the potential reward, the proof that we are not alone, was too profound to ignore. And so they kept listening, night after night, letting the data pour in and using ever-improving computers to sift through it for any hint of something unnatural. From time to time, the silence would break, or so it seemed. In 1967, a graduate student in England named Jocelyn Bell noticed a peculiar pulsing in her radio data. It was a series of blips so regular and quick that it almost felt like a beacon. The team half-jokingly labelled the source LGM1, short for Little Green Men 1, amusing themselves with the thought that perhaps they had stumbled upon an alien signal. In reality, they had discovered the first pulsar, a rapidly spinning neutron star flashing its lighthouse-like beam toward Earth multiple times per second. It was a natural phenomenon, not an extraterrestrial greeting, but for a brief moment it had tantalized scientists with the possibility of a cosmic hello. Even after it became clear that the signal was just an exotic star, that moment of wonder left a deep impression, a reminder that the universe could surprise us, and that one day one of those surprises might indeed be a message from another mind. A decade later, another strange whisper from the sky stirred excitement. In the summer of 1977, at an observatory in Ohio, an astronomer was reviewing printouts from a radio telescope when something unusual leapt out. Amid columns of dull numbers was a sudden spike, a strong, clear signal, unlike the usual background noise. Startled, he grabbed a red pen and circled it, scribbling "wow" in the margin. That one word became the signal's nickname, the legendary "wow" signal. It came from the direction of the constellation Sagittarius and lasted nearly a minute before disappearing. No one heard it in real time. It was discovered in the data after the fact. When they hurried to point the telescope back to that patch of sky, the signal was gone, never to be heard again. To this day, the wow signal remains an enticing mystery. Was it a stray broadcast from a distant civilization? A freak natural burst from some unknown cosmic source? Decades have passed without a definitive answer. It was a whisper that left an echo of wonder, and then silence once more. Yet that single wow continues to inspire SETI researchers to keep looking, hoping that another such signal might someday appear, perhaps one that repeats and can be confirmed. As the search continued, there were other false alarms and fleeting glimmers. In one instance, a team thought they'd found something extraordinary, only to realize it was a stray transmission from an Earth satellite passing overhead. In another, mysterious repeating bursts perplexed astronomers until they traced them to an unlikely culprit. A microwave oven in the observatory's break room opened at just the wrong moments during an experiment. And more than once, a mobile phone accidentally left on near an antenna sent everyone into a brief frenzy over a signal that turned out to be simply human technology in disguise. These episodes often ended with relieved laughter and sometimes a bit of chagrin, but each taught a lesson in vigilance. The universe wasn't teasing us on purpose. We just had to become more cunning at distinguishing alien whispers from our own noise. So the scientists refined their methods, improved their equipment, and continued their vigil with ever greater rigor. Year after year, the vast sky has revealed many marvels: exploding stars, colliding galaxies, the faint hiss of cosmic background radiation left from the universe's birth, but no unmistakable call from another intelligence. The data streams in as a ceaseless, quiet rush. The telescopes record the cosmic silence, broken only by natural phenomena. Far from discouraging the listeners, this quiet has only deepened their resolve. Each empty result is a reminder of how momentous it would be if a signal were found. It's as if the very rarity of success makes the pursuit even more meaningful. In the quiet darkness, under pinpricks of ancient starlight, the scientists lean forward a little more keenly, determined not to miss even the faintest whisper that might break the silence. Imagine the patience it takes. Hours, nights, years spent sifting through static that never resolves into anything familiar. It's like listening for a single note of music in a cacophony of noise. Yet within that noise could lie the answer to one of humanity's oldest questions. Are we alone? Or is there someone else out there trying, perhaps, to reach us as well? That question keeps their eyes on the readouts and their ears tuned to the sky, long after midnight and into the silent dawn. In the solitude of these observatories, with only the hum of equipment and the glittering firmament for company, one can't help but wonder, if there are other beings out there with minds and curiosity, might they also be listening? Perhaps on a planet orbiting a distant sun, someone stands under alien constellations, tuning their own receiver and hoping for a sign that they are not alone. Across the light years, both civilizations might be straining to hear each other, like two lonely travelers calling out in a fog, each hoping to find a companion. So far, only silence bridges the gap. We continue to aim our radio ears at the stars, listening for a cosmic companion, a friend we have never met, whose voice we have never heard, but whom we suspect might be out there in the dark. And while we listen, we also feel the urge to reach outward. If the universe isn't speaking to us yet, perhaps we should speak first. Perhaps we should send our own message into the unknown, a cosmic greeting from Earth to whatever other ears may be listening out there. For nearly a century, Earth itself has been broadcasting into the cosmos, though we didn't always mean to. Ever since we invented radio, our signals have been leaking into space, an expanding bubble of earthly chatter. Early radio shows, news bulletins, comedy hours, and musical programs from the 1920s and 30s. All those voices and tunes spilled out beyond our atmosphere and are now drifting among the stars. The first television transmissions, grainy black and white images of historical events and daily life from the mid-20th century, are also racing away at the speed of light. By now, some of our earliest broadcast waves have journeyed over 100 light-years from Earth. For instance, the television coverage of the 1936 Olympic Games in Berlin, one of the first powerful global broadcasts, has already travelled more than 80 light-years outward, carrying with it a ghostly snapshot of humanity in that era. These signals grow weaker as they spread out, and eventually they fade into the cosmic background. But in theory, they continue on, forming a faint, ever-expanding sphere centered on our planet. It is as if, without any intention, we have been announcing to the universe that a technological civilization resides here on a small blue world. It took time for us to realize that we had inadvertently become beacons. By the mid-20th century, scientists understood that all our radio and TV chatter was escaping Earth and filling the surrounding space. Once we recognized this, a bold idea emerged. Why not send a deliberate message to the stars? Instead of simply hoping someone stumbles upon our leaked signals, we could craft a focused greeting that says, "Hello, we are here, and this is who we are." For years, this concept remained in the realm of speculation and science fiction. But in the early 1970s, it moved into reality. In 1974, scientists gathered at the Arecibo Observatory in Puerto Rico to dedicate a major upgrade to its giant radio telescope. To commemorate the moment, they did something audacious. They sent a cosmic postcard. Using the observatory's powerful transmitter, they beamed a tightly focused radio signal toward a distant globular star cluster called M13. This signal, known as the Arecibo message, lasted only 3 minutes, but packed in a treasure trove of information coded in binary form. It was essentially a pictogram, a pattern of bits that, when arranged correctly, would form simple images and symbols. In that brief transmission, we included basic facts about humanity and our planet, the numbers 1 through 10, the atomic numbers of elements important to life, a sketch of the double helix structure of DNA, a stick figure of a human being with an indication of our average height, a diagram of our solar system with Earth highlighted, and a simple graphic of the Arecibo telescope itself. It was humanity's way of saying, "Hello, we are here. This is some of what we're about." The scientists and engineers knew full well that M13 was about 25,000 light-years away. Even travelling at light speed, their message would not arrive until the far distant future, long after everyone sending it would be dust, and indeed long after the cluster itself will have moved to a different position. In all likelihood, no one will ever receive it. And yet, there was a profound optimism in the act. As the signal left Earth, riding a radio beam into the deep night, those present felt they were part of a moment that stretched human greetings far beyond our tiny sphere. The exercise was as much symbolic as practical, a statement of hope and technological daring. Not all our messages have ridden on radio waves. Around the same time, we began to send physical tokens of ourselves into the cosmos. In 1972, the spacecraft Pioneer 10 was launched on a trajectory that would eventually take it out of the solar system. Attached to its supporting struts was a small gold anodized aluminum plaque. On this plaque, scientists inscribed a message in the universal language of pictures and physics. It showed the figures of a man and a woman, drawn simply and without clothing, the man's hand raised in a friendly wave. There were also symbols to convey where this spacecraft came from. A schematic of our solar system with a little arrow indicating Pioneer's departure path, and a pattern of lines radiating from a central point. A map using pulsars as reference beacons, intended to pinpoint the location of our sun in the galaxy. The message was modest and static, but it was the first physical artifact we deliberately sent out representing humankind. A year later, Pioneer 11 carried an identical plaque as it too ventured toward the stars. These plaques are like golden business cards bearing our return address, quietly sailing into interstellar space. Then came the Voyagers. Voyager 1 and Voyager 2 were twin probes launched in 1977 to explore the outer planets. Knowing that these spacecraft would eventually drift eternally through the Milky Way, a team led by astronomer Carl Sagan assembled a more ambitious message to accompany them. Affixed to each Voyager was a gold-plated phonograph record, the famous Voyager Golden Record, containing sounds and images from Earth. Engraved on its cover were instructions for any finder on how to play it, and a star map, similar to the Pioneer plaques, showing our sun's location. If an alien civilization ever finds Voyager and plays the record, what would they hear? To start, they'd hear greetings in 55 different human languages. People from all over our world saying hello in their own tongues. They would hear a mother softly whispering to her newborn baby, the joyful laughter of children at play, the patter of rain and the roar of surf, the songs of birds and the calls of whales echoing through the oceans. Music from around the globe was included. Classical compositions by Bach and Beethoven, spirited rock and roll from Chuck Berry, folk melodies and chants from different cultures. There were also encoded images, photographs of Earth's landscapes, of humans of many ethnicities and ages, diagrams of human anatomy, and scenes of life from elephants in the savannah to a silhouette of a city skyline. It was an incredibly thoughtful capsule of earthly life, meant to represent the essence of our world and convey a welcoming message. This is Earth. These are our sounds and visions. We exist, and we reach out to you across the cosmic sea. Voyager 1 and 2 have long since completed their grand tour of the planets and slipped beyond Pluto's orbit into the vast dark between the stars. Voyager 1 is now the farthest human-made object from Earth, billions of miles away and counting. It has entered interstellar space, the region beyond the sun's influence. It will be tens of thousands of years before it comes remotely close to another star, and even close in this context means a few light years. Voyager 2, on a different path, is not far behind. These silent envoys will wander the galaxy for millions of years, carrying their golden records like messages in bottles. The odds that anyone will find them are incredibly small. Space is unimaginably vast, and the Voyagers are tiny specks gliding in a cosmic ocean. But even if those records are never intercepted, they serve a purpose for us here and now. They are bold declarations that we were here and we wanted to say hello. They carry the dreams and the sounds of Earth far beyond our shores. In a sense, they are our gifts to the universe, offerings of our curiosity and goodwill, sent out in hope, even without knowing if anyone will ever encounter them. In the decades after Voyager's launch, humanity continued to send the occasional intentional message toward the stars. In 1999, and again in 2003, for example, scientists and enthusiasts used a radio telescope in Evpatoria, Ukraine, to transmit powerful signals toward a handful of nearby sun-like stars. These messages were called the cosmic calls. They carried encoded information about mathematics and science, as well as text greetings and drawings from people on Earth, all designed in the hope that an extraterrestrial intelligence might decipher them. Around the same time, another project in Evpatoria sent what they dubbed the Teenage Message, a broadcast that included music composed by teenagers and personal salutations from young people, beamed into the cosmos as a friendly gesture from the next generation of humanity. In 2008, a collaborative effort from Earth beamed a digital time capsule named A Message from Earth toward a planet called Gliese 581c, which orbits a star about 20 light-years away. That particular target was chosen because Gliese 581c had been identified as a potentially habitable world, a place that could, just maybe, harbour life. Our focused greeting, containing hundreds of text messages and images submitted by people around the globe, was sent via a high-powered radar transmitter. It will take about 2 decades to reach that distant solar system. If by some remote chance someone there is listening and decides to reply immediately, we wouldn't receive their answer until many decades later, perhaps around the middle of this century. It's a slim chance, but imagining that scenario of a far-off civilization receiving our digital bottle and sending their own message back is a thrill in itself. Not everyone agrees that actively sending out our presence is prudent. Some scientists have pointed out that we cannot be certain who might be listening. The late physicist Stephen Hawking, for instance, cautioned that encountering a far more advanced civilization could be risky for us. He likened it to Native Americans meeting European explorers, which did not end well for the less advanced side. This perspective suggests that maybe we should be very careful about shouting into the cosmic forest before we know what might be out there. Others counter that the distances are so vast and the likelihood of interception so low that these messages pose no significant danger, and that the desire to connect outweighs the fear. They also note that Earth's radio leakage has already been announcing our presence for decades regardless. This debate remains largely theoretical, but it reflects a real tension between curiosity and caution. In reaching out to the unknown, we accept that we cannot predict what we might find. Yet our nature tends toward exploration and communication rather than silence and hiding. And so, through consensus or individual initiative, we have continued to send our cosmic greetings, choosing hope over hesitation. Each of these messages from Earth, whether a broadcast or a spacecraft carrying a golden disk, is like a bottle cast into a vast ocean. We don't know if that ocean even has any other travelers, or if our bottle will ever wash up on some distant shore under alien skies. Perhaps our messages will drift forever, unheard. Or perhaps, someday far in the future, a curious mind very different from ours will come upon one of them and recognize it as a greeting from another civilization. The thought of that distant connection is powerful. It speaks to something fundamental in us, a yearning not to be alone, a need to reach beyond the confines of our world and touch the unknown. For now, there has been no reply. No answering signal has flickered back to our radio telescopes. No voice from the darkness responding to our calls. Our messages sail outward, and the stars remain silent. We continue to listen to the sky, hoping for any hint of a reply, but so far we have heard only the natural background chorus of the cosmos, the sighs of solar winds, the crackle of magnetic fields, the distant hum of galaxies. It feels at times as though we have been calling out into a grand canyon and hearing only our own echoes. This persistent quiet, this absence of any confirmed response, has come to be known by a somber name: the Great Silence. In a galaxy that our scientific estimates suggest should be full of possibilities for life, the lack of any sign from other technological civilizations is a mystery that grows deeper with each passing year. Why, many wonder, have we heard nothing back? With so many stars, and presumably so many planets, how can the cosmos feel so silent? These questions lead us into one of the most profound puzzles of our age. If others are out there, why haven't they spoken? And what does that silence mean? The paradox of the Great Silence weighs on minds of astronomers and philosophers alike. If the galaxy is so vast and old, and if life could have arisen on many worlds, why is it so quiet? This conundrum was famously captured in a straightforward yet profound question posed in 1950 by physicist Enrico Fermi during a casual lunch. Where is everybody? In a universe filled with hundreds of billions of stars and untold planets, one might expect at least some other voices by now. Yet all we hear is a great hush. Over the years, many ideas have been offered to explain this silence, each like a piece of a puzzle, suggesting a different aspect of a possible answer. One possibility is that we are truly alone, or at least exceedingly rare. Perhaps life, especially intelligent, technologically capable life, is far more uncommon than we imagine. It could be that the conditions needed for life like ours occur only in a few precious places and moments. If that's the case, then there simply may be no one nearby to hear or to speak. We might be like an isolated tree in an otherwise empty plain, calling out and hearing nothing back because no other tree stands within earshot. In this scenario, the silence isn't mysterious at all. It's exactly what we'd expect if we really are alone. The nearest civilization might be so far away that our signals haven't reached them yet, and theirs haven't reached us. Our galaxy might hold only one oasis of conscious life at a time, and it could be right here on Earth. Another sobering idea is that many civilizations may have arisen across the eons, but most have since gone extinct or fallen silent. Life might spark and flourish on many worlds, only to hit roadblocks or self-destruct as it becomes advanced. Catastrophic wars, ecological collapses, or other self-inflicted disasters could snuff out societies before they ever get the chance to reach out to the stars. Or perhaps nature itself often deals harsh blows. Supernova explosions, gamma-ray bursts, massive asteroid impacts, events that could regularly reset the evolutionary clock on otherwise life-bearing planets. If technological civilizations tend to be short-lived, their detectable signals might be brief flickers in the darkness. By the time their radio whispers reach us, they may already be long gone. One by one, lights may have turned on and then off across the galaxy, with none lasting long enough to meet another. It's unsettling to think that the cosmos might be littered with silent remnants of societies that prospered for a time and then vanished. We on Earth fret about our own vulnerabilities too. Nuclear weapons, climate change, pandemics. It's a chilling thought. The Great Silence could be a graveyard hush, not because no one else ever was, but because they didn't endure. There is also the possibility that intelligent beings are out there, but choose not to communicate openly, at least not with upstart civilizations like ours. Maybe there is a galactic rule, or a common ethos of non-interference, akin to a prime directive. Some have whimsically called this the zoo hypothesis, the idea that we are like animals in a cosmic wildlife sanctuary, observed from afar, but not contacted so that we can develop naturally. If true, the quiet sky would be a kind of imposed silence, our cosmic neighbours intentionally staying quiet, waiting for us to reach a certain level of maturity before making themselves known. One can imagine that if we ever meet certain criteria, technologically or ethically, the silence might end with a friendly welcome. It's entirely speculative, of course, but it's a hopeful scenario. The universe could be teeming with life that's simply watching and waiting for humanity to come of age. On the darker end of speculation lies the notion that everyone is hiding because something dangerous lurks. In a universe full of unknowns, perhaps caution is the rule. One imaginative scenario, popularized in science fiction, likens the cosmos to a dark forest where every civilization keeps quiet and camouflaged. After all, if you shout in a dark forest, you never know what might hear you. The idea is that broadcasting your presence could attract predators or hostile intelligences, so the safest course is to remain silent and unseen. In this grim vision, the wise civilizations listen but never transmit, and the universe appears quiet because everyone who knows better is keeping their head down. If this theory held true, our own attempts to signal outward, our cosmic yoo-hoos, like the Arecibo message or television broadcasts, might be akin to recklessly lighting a beacon in that dark forest, potentially drawing eyes we'd rather not meet. It's a paranoid thought, suggesting that the great silence might be an active, deliberate quiet maintained out of fear. Of course, the explanations may not be so dramatic. It could simply be that we haven't been listening long enough or hard enough, and the cosmic timing hasn't aligned. Our own search has been underway for only a few decades, a blink of an eye on the cosmic scale. The first radio waves we emitted have barely washed out into our neighbourhood of stars. It's entirely possible that signals from a civilization 1,000 or 10,000 light years away just haven't arrived yet, or that our signals haven't reached them. We might be like two sailors on a vast ocean, sending up flares at different times. Unless our timing coincides, we would never spot each other. One SETI pioneer, Jill Tarter, illustrated our limited search by comparing it to scooping a single glass of water from the ocean to check for fish. Finding no fish in that one glass doesn't prove the ocean is empty. It only tells us we need to sample a whole lot more. Similarly, by late 20th century estimates, all the SETI listening we had done was equivalent to examining a few drops of water from that ocean of possibilities. The silence we've heard so far might simply mean we haven't looked in the right place yet, or that we've only just begun to listen in a concert that's been playing for millions of years. Then there's the chance that we are looking for the wrong signs, essentially tuning the wrong station. Most SETI efforts have focused on radio waves, with some also checking for optical laser pulses. But an alien society might communicate using methods we haven't even conceived of. They could be sending neutrino beams through space, or manipulating gravity waves, or using some exotic quantum communication. Those would fly right past us unnoticed, because we're not equipped to detect or decode them. It's akin to trying to tune into an FM radio station with an AM radio. The signal could be blasting away clearly, but we'd never know with the wrong receiver. Until we widen the scope of what we consider a possible signal, we might remain oblivious to an ongoing galactic conversation. Our current tools limit what we can perceive, but as technology improves and we become open to new ideas, perhaps we'll stumble upon communication methods that were previously invisible to us. Likewise, it could be that we've already seen hints of something and not recognized it. There have been tantalizing puzzles in our observations, strange phenomena that made us scratch our heads. One example is the star nicknamed Tabby's star, which dimmed in an odd, irregular fashion that didn't fit any simple pattern. For a time, some speculated about alien megastructures, like a colossal array of solar collectors, orbiting that star, causing the weird dips in light. Further study pointed to dust and natural causes as more likely explanations, and indeed no evidence of artifices has been found there. But the very fact that such an idea was seriously considered shows how prepared we are to pounce on any anomaly that could hint at intelligence. It reminds us that a message might not come in the form of a deliberate transmission at all. It could be an odd chemical signature in a distant planet's atmosphere, or a peculiar pattern in cosmic energy emissions. We might have to play cosmic detective, piecing together indirect clues of technology, rather than receiving a straightforward greeting. Scientists have tried to get a handle on the likelihood of others out there by using an equation, famously proposed by Frank Drake in 1961, that multiplies together various factors: the number of stars formed per year, the fraction of those stars with planets, the fraction of planets that could support life, the fraction of those that actually develop life, the fraction of life that becomes intelligent, the fraction of intelligent life that develops communication technologies, and finally, the average lifespan of such civilizations. This Drake equation doesn't spit out a firm answer, but it provides a way to organize our ignorance. Depending on the values one plugs in, and many of those values are still educated guesses at best, the equation can yield a galaxy teeming with dozens or hundreds of civilizations. Or, at the other extreme, it can suggest that we might indeed be the only technological society in the galaxy at this time. Over the decades, we have made progress on at least some of those factors. For example, we now know that planets are extremely common. Virtually every star has at least one, and small rocky planets like Earth are abundant. That discovery pushes up the odds that life-friendly environments are out there. But other factors remain mysterious. How often does life actually get started? How often does it evolve intelligence? How long do technological societies last? The Great Silence itself is a piece of evidence. It could imply that advanced life is rare, or that advanced civilizations have very brief windows of detectability. Or it might mean that if life is out there, it isn't using any methods we can detect, or perhaps chooses not to. In the end, the Drake equation shows us that there are many possible filters that might prevent worlds from ringing out with signals. And maybe, on most planets, one filter or another eventually silences the inhabitants before they ever get a chance to be noticed. In truth, we don't know which, if any, of these explanations, or others we haven't imagined, is correct. The reality could be some combination of factors, or something entirely unforeseen. Until we detect a clear signal, or find unambiguous evidence of alien technology, the Great Silence remains an unanswered question, and one that says as much about us as about the cosmos. It can be disheartening to consider that we might be alone, looking up at a sky of countless stars and envisioning only empty worlds is a lonely picture. Yet the silence also spurs our resolve and our imagination. The very lack of evidence, the emptiness of our radio skies, means that if a signal does come, it would change everything in an instant. And that sliver of possibility energizes those who continue the search. So, what do we do in the face of the silence? We persevere. The reaction of the scientists and dreamers involved in SETI has not been to give up, but rather to listen more carefully, search more cleverly, and expand our efforts. If answers aren't obvious now, maybe we haven't asked the right questions yet. Or maybe we need better tools, more time, and more ears on the sky. The cosmos is immense and ancient. By comparison, our search has just begun. As long as the silence continues, we will keep probing it, fueled by the hope that one day it will be broken. One generation of researchers passes the torch to the next, along with that enduring hope. The great silence, frustrating as it is, has not quenched our optimism. In some ways, it has made that optimism burn more brightly. We vividly imagine how profound the moment of contact would be, how it would reshape our world, and that vision motivates us through the quiet nights. For now, we remain listeners in the dark, determined, patient, and filled with a quiet faith that somewhere in that cosmic silence, there is a voice waiting to be heard. We will keep listening and keep looking, no matter how long it takes, because the question, are we alone, is too important, too wondrous to abandon. In the face of the silent sky, we choose hope. We choose to continue the search, still listening for a whisper in the cosmic night. Under the dome of the night sky, the search continues with renewed energy. Our technology has leapt forward since the days when Frank Drake first tuned into the stars. Now, multiple giant ears are listening to the cosmos, far more sensitive and far-reaching than before. In the mountains of West Virginia, the Green Bank Telescope, a dish as tall as a skyscraper, sweeps slowly across the starry fields, its receivers tuned to frequencies where the cosmic radio background is naturally quiet. This telescope sits in a designated National Radio Quiet Zone. Here, cell phones, Wi-Fi, and other transmitters are kept to a minimum, so that earthly chatter doesn't drown out whispers from the sky. On a clear night at Green Bank, you might hear little more than the crickets and the soft whir of the telescope's motors beneath a canopy of glittering stars. Across the ocean in Australia, an array of dozens of dishes called ASCAP is spread out over the red plains of the outback, working together in unison. It scans broad swathes of the sky for anything unusual, effectively acting as one giant instrument with many eyes. And in a remote natural basin in southwest China sits the largest single-aperture radio telescope on Earth, a colossal bowl 500 meters across, known as FAST. Cradled by green karst hills, FAST peers upward with unparalleled sensitivity, able to detect incredibly faint signals. Villages near the site were even relocated to reduce radio interference, underscoring how much we strive to give this big ear the silence it needs to listen. Each of these instruments, and others like them around the world, is part of a global concerted effort to finally catch that elusive cosmic call. One of the most ambitious initiatives to date is a program called Breakthrough Listen. Launched in the mid-2010s, with funding from tech entrepreneurs and guided by leading astronomers, with Stephen Hawking himself lending support at its announcement, Breakthrough Listen has supercharged SETI. It has given some of the world's premier telescopes, including Green Bank and the Parkes Observatory in Australia, thousands of hours to devote exclusively to scanning the skies. They are targeting up to 1 million nearby stars across a huge range of radio frequencies, while also checking for extremely short laser pulses that might signify an interstellar beacon. The volume of data gathered is enormous, far too much for any person to sift through. Instead, supercomputers, and formerly millions of volunteer PCs through SETI at home, help to analyze it all, looking for signals that stand out from the natural background noise. Sophisticated algorithms and machine learning software comb through these torrents of data, trying to pick out the faintest hint of something that isn't random or isn't from an astronomical source. Every so often, they do find strange spikes or patterns. And when that happens, the first question is always whether it was generated by us. Most of the time, these intriguing candidates turn out to be earthly interference of one sort or another. A stray communication satellite, a high-flying aircraft, a glitch in the electronics. But every once in a while, something truly odd emerges that doesn't have an easy, mundane explanation. And that's when the excitement quietly builds. Meanwhile, the discovery of planets beyond our solar system, exoplanets, has utterly transformed our perspective. We now know of thousands of such planets, and more are found every year. Some are tantalizingly similar in size and orbit to Earth. Whenever a potentially Earth-like planet is identified in a star's habitable zone, hope surges anew. Perhaps this world has life, maybe even intelligent life looking up at their sky. NASA's Kepler and TESS space telescopes have revealed that planets are incredibly common. Nearly every star is now thought to host at least one. Among those myriad worlds, a fraction reside at just the right distance from their suns for liquid water to exist. We've found a handful of rocky planets that could have the temperate conditions for life as we know it. That knowledge makes the silence we've encountered more perplexing, but it also fuels our determination to keep searching. If life could emerge here on Earth, why not elsewhere? Statistically, it seems it should have, somewhere, perhaps many times. And indeed, as we find planets around our closest stellar neighbours, the question, could someone there be listening to us, becomes more than an abstraction. The discovery of Proxima b around Proxima Centauri, the nearest star to our Sun, and several Earth-sized planets around the star, TRAPPIST-1, only 40 light-years away, makes the possibility of nearby life feel within reach. To improve our chances of finding signals, scientists are not only building bigger ears, but also diversifying how we listen. Optical SETI is one such approach. Instead of radio waves, it looks for ultra-brief flashes of laser light that an advanced civilization might use to communicate. Large optical telescopes stare at nearby stars with sensitive detectors, seeking any sudden pulses of light that are too sharp and regular to be natural. So far, none of the candidate flashes have proven to be extraterrestrial signals. But the search in the optical realm has really only begun. There are even concepts for using completely different messengers. Perhaps a civilization could modulate neutrinos, ghostly particles that pass through almost anything, or gravitational waves, ripples in space-time itself, to send information. These ideas sound like science fiction to us, and we currently have no easy way to eavesdrop on such methods. But we keep an open mind. Our own technology limits what we can detect, but it's constantly improving. As we gain new tools, better telescopes, novel detectors, clever algorithms, our ears become sharper and our eyes more discerning. We widen the range of cosmic channels we're able to monitor. Who knows what we might catch as our capabilities grow? Human ingenuity is also turning inward to meet the challenge of the great silence. The hunt for a signal hidden in cosmic noise is as much about computation as observation. We're increasingly relying on artificial intelligence to sift through data and recognize patterns that might elude the human eye. Machine learning systems are being trained on simulated signals to learn what to look for amid the static. In essence, we're teaching our systems how to be better eavesdroppers on our behalf, preparing them to notice even a faint, anomalous whisper from afar. Moreover, citizen science continues to play a role in SETI. For years, volunteers around the world joined the search by contributing their home computer's processing power to analyze telescope data via SETI at home. That screensaver-style program allowed millions of everyday people to help crunch the numbers, turning a worldwide network of idle PCs into a supercomputer scanning for aliens. The SETI at-home project has paused since completing its initial data sweep, but its legacy endures in the enthusiastic public interest it cultivated. New citizen science projects are carrying that spirit forward. Amateur astronomers with modest radio setups sometimes undertake their own sky surveys, and groups of hobbyists participate in signal classification or anomaly hunting through online platforms. The dream of discovering we're not alone resonates with people everywhere, and SETI has become a global, shared endeavor. It's a search that transcends borders and unites us in wonder. Every so often, a spike of excitement runs through the tight-knit SETI community when a potential signal is detected. Scientists have protocols for such moments. Verify relentlessly, stay quiet until you're sure, and systematically rule out all terrestrial explanations. In recent years, one such candidate signal drew attention during Breakthrough Listen's observations of Proxima Centauri, our nearest stellar neighbor. For a time, this enigmatic narrow-band transmission, dubbed simply BLC-1, Breakthrough Listen Candidate 1, had no obvious explanation as human-made or natural. It had some of the characteristics one might expect from an artificial source beyond Earth. Those who were working on the data were cautiously electrified. Could this be it? Could we finally be eavesdropping on an alien transmitter in our cosmic backyard? For months, they analyzed the signal in secret, checking every conceivable interference source and using other telescopes to try to hear it again. In the end, the signal was traced to an earthly origin, likely some mundane technology on our own planet that by coincidence mimicked the kind of signal we seek. It was a disappointment, of course, but the rigorous vetting process it triggered was a valuable dry run for the real thing. Each time something like this happens, it's a learning experience that makes us better prepared. The instruments get fine-tuned, our software filters get smarter at recognizing interference, and the team grows even more adept at distinguishing false alarms from a true cosmic whisper. These false starts also remind everyone that the first confirmed detection will need extraordinary evidence. No one in the field wants to cry wolf about alien signals and then have to retract it. Caution is the watchword. So while the occasional media flurry about a mystery space signal might raise hopes briefly, behind the scenes, the scientists methodically work through each possibility, letting the data and a healthy dose of skepticism lead them to a verdict. So far, every candidate has been explained or fizzled out, but each has kept us on our toes. As we refine our listening, we're also considering how we might respond if we ever do hear that long-awaited hello. In fact, the SETI community has had a set of agreed-upon guidelines for decades about what to do in the event of detection. The plan, in essence, is confirm the signal beyond doubt, then inform the global scientific community and relevant authorities, like the United Nations, and make the discovery public. Only after international consultation would any reply be composed and sent. And even that is a matter of debate. There's the profound question of whether we should respond at all, or simply listen. Some argue that perhaps we should remain quiet a bit longer. After all, any civilization we detect is likely to be far older and more advanced, and caution might be prudent until we learn more about them. Others feel that if they've gone to the trouble of sending a message, even unintentionally, basic courtesy would be to acknowledge it. At the moment, these discussions remain hypothetical, academic exercises, but they're important. They show that we humans are taking the prospect of contact seriously enough to prepare, even before it happens. In a way, drawing up first contact protocols is a quietly hopeful act. It indicates that we believe, on some level, that the scenario will one day be real. For now, we remain in the quiet night, with our instruments turned skyward and our hopes alive. The quiet itself is not empty. It's filled with our collective curiosity and anticipation. Each time a radio dish slews to a new target star, each time a fresh batch of data is processed, there's a flicker of optimism. The scientists might not say it aloud, but it's there in the back of their minds. Maybe this time. Decades have rolled by with no confirmed signal, and yet, instead of fading, the effort has intensified and spread. Our searches cover more sky, more frequencies, and more types of signals than ever before. Our ears have become far keener, and our analysis more sophisticated. We've learned patience on a scale that befits the cosmos itself. Picture a night at one of those observatories. The control room is quiet. Monitors glow softly with readings. Outside, the great dish moves under a spangle of stars. A lone researcher steps outside for a short break. The air is cool and still, and the Milky Way arches overhead like a gauzy river of light. She pulls her sweater a little tighter and gazes up. Above her, countless stars shine, each a sun that might have planets and perhaps life. Somewhere out there, she knows, are the planets discovered by Kepler and Tess, and countless others, yet undetected. She can't help but wonder which of those pinpoints of light might host a fellow thinker gazing back in our direction. The night is silent, but brimful of possibility. In that moment, the enormity of what she and her colleagues are attempting truly hits home. They are trying to bridge an unfathomable gulf, to connect two worlds across light years. It's humbling and awe-inspiring. The silence isn't discouraging. If anything, it feels majestic, like the hush in a great cathedral. The researcher smiles at the thought, her breath a mist in the cold air. After a few more minutes under the stars, she heads back inside to her post. There are readings to monitor, and the telescope has many more targets to capture before dawn. The search goes on. No one can say how long we will need to listen. It could happen tomorrow. Some algorithm might flag a signal in our data that, upon checking, turns out to be the real thing. It could happen a century from now, after we've combed through millions of stars. It might require new kinds of telescopes or receivers, perhaps placed out in space or on the moon's far side where Earth's din can't reach, to finally detect a faint call from a distant world. We may even decide to take a more active role. Projects like Breakthrough Starshot have been proposed to send tiny, laser-propelled probes to the nearest stars, which within a few decades could beam back close-up observations of those systems. Maybe one day, a probe like that will find evidence of someone out there, if our ears on Earth remain empty. However long it takes, it seems likely that humans will keep at this quest. The search for cosmic company has woven itself into our scientific narrative. It's an expression of our innate curiosity and our longing for connection. We listen not because we're certain we'll hear something, but because if we don't listen, the chance of success drops to zero. The act of listening is, in a way, its own affirmation of hope. And so, under the silent canopy of stars, we carry on. We listen with the best tools we have, with minds open to wonder and hearts resiliently hopeful. Each faint whisper from the telescope's speakers, each mysterious pattern in a computer printout, is like a syllable in a conversation that hasn't happened yet. We lean in to catch everyone, until that day when a true signal finally arrives, if it ever does. We find meaning in the search itself. It brings us together in a shared vigil, reminding us that even in our solitude we are united by the quest to know more, to reach further. Still, one can't help but imagine, perhaps even now, a signal is on its way toward us, faint and travelling across light years, carrying greetings from a civilization we've yet to meet. Or perhaps they too have been patiently listening, waiting for a sign from our little world. For all we know, the universe might be waiting for the right moment, the right alignment of curiosity, technology, and time, for that connection to be made. Until that moment arrives, we remain here on our pale blue dot, with our radio ears aimed at the heavens and our imaginations soaring among the stars. We are, as ever, still listening and still hoping.